Do you want to build your own 2D tower defense game from scratch, even if you're a total beginner? In this course, we'll create a fully functional scalable game with multiple tower options and enemy types, all powered by easy-to-manage scriptable objects. You'll also learn how to set up scene transitions, menus, pause and restart features, and even an endless mode to keep players hooked. And the best part? The game uses placeholder art, so you can customize the visuals however you want. If you enjoy tower defense games like Kingdom Rush, Plants vs Zombies or Bloons, why not learn how they work under the hood? Click the like if you want me to make more classes like this, and let me know which other game genres I should cover next. I create a new blank project with universal 2D render pipeline. I'm using Unity 6, but you can use any Unity version you want, it doesn't matter. In Assets Scenes, I rename my scene to Game. Inside the Assets folder, I create a new folder I call Art. You can download all art assets in the Resources section below. My name is Frank, and I've built hundreds of minigames across multiple programming languages. This course is designed with beginners in mind. Every step includes downloadable source code you can open directly in Unity, so you're always working with the exact version I'm using, making it super easy to follow along. Let's build our own tower defense game in Unity with all the essential features. This class is for complete beginners, but I expect you have built at least a small project in Unity before. I'll start with this simple spreadsheet, where I have one frame representing an enemy and another frame representing a point along a path. With the image asset selected inside the Inspector tab, if you're using pixel art like this image, you want to make sure it's not blurry. So we set filter mode to point no filter and compression to none. I click apply, I open the sprite editor and slice, grid by cell size. These frames are 100 x 100 pixels. I click slice, then apply. Now I can use this little arrow to expand the sprite sheet and see individual frames. Here in the hierarchy window, I see all the game objects that make up my game scene. I can right-click and create an empty game object. I call it Path. Every game object in Unity has a transform component, which defines the object's position, rotation, and scale. We can use these tools here. For example, I can select the Move tool to move the object around the scene. And when I do that, its position values change. I can also right-click and reset transform to center the object in the middle at coordinates 0, 0. So this is the game scene. This white rectangle represents the visible game area. If I open the Game tab, this is what the game will actually look like when played. In my Art folder, I can expand my sprite sheet. If I drag and drop this frame into the scene, Unity will automatically create a game object for it. Unity will also automatically detect that this game object has an image. So on top of its transform component, it will also give it a sprite renderer component, where we can do many things to handle and adjust the image. I will rename the game object to Waypoint. With the Waypoint game object selected, I can use the Move tool to move it around the scene. Doing that will update its X and Y position. I can also set the object's position manually by changing these values here. On the Game tab, this is what our game looks like so far. I'll change the aspect ratio to Full HD for better rendering, and I'll zoom out using this scale slider. I like to keep my small game preview down here. Now, when I make changes to the scene, I can instantly see how those changes affect the playable version of my game. Now that we understand the basic Unity layout, let's build something more interesting. Inside my Assets folder, I create a new folder I call Prefabs. I can drag and drop my Waypoint game object into this Prefabs folder, turning it into a reusable game asset. Prefabs are pre-configured, prefabricated game objects. Let's say I have a game object like this Waypoint, and I configured it in a specific way. Now I want multiple of these game objects, all configured the same way. Instead of repeating the process over and over, configuring them one by one, I turn it into a prefab and I can duplicate it as many times as I want. Notice that after turning it into a prefab, it changed color. I can delete it from the scene now, and I can just drag in as many as I need. If I want to make change to all of these copies, I can just change the main prefab in Assets and it will update all of them. I delete these and I leave just one for now. Game objects in Unity have components that give them special functionalities. Unity has many components we can add, and we can also create completely custom script components to write custom logic. So let's say I want to write a simple script that connects all of our waypoints with a line, and I want enemies to move and follow along that path. Inside Assets, I create a scripts folder. In Unity, we use the C# programming language. Let me show you how much you can achieve with just a few simple lines of code. Inside the scripts folder, I right-click, create, and I choose a monobehavior script. I call it path. Be careful here, you can't just rename this file later, because Unity will use that name to define the class inside the file. So make sure the name of your file and the auto-generated class name inside it match. I select the path game object and I attach the path script as a custom component, like this. I double-click the script file and Unity opens it in my default code editor. If you've never heard of monobehavior before, all you need to know is that it's a special Unity class that allows us to take scripts and attach them to game objects as components, just like we did, and make the code inside that script interact with that game object and with others in the scene. Monobehavior is a fundamental building block of Unity. You'll see it all the time. Monobehavior also gives us access to so-called lifecycle methods, useful code blocks where we can put our code depending on when we want that code to run. You can also see that Unity created two most important methods. Inside the start method, we can put code we want to run only once at the beginning, and the update method is where we put code we want to run over and over. There are many more built-in lifecycle methods, and we will use some later on. For now, to keep this clean, I will delete them and I will just declare a variable. We are inside a custom path class we created. I want a variable that will hold an array of waypoints so that we can connect them together and send enemies along that path. In C#, we define variable this way. We start with an access modifier. If the variable is public, then everyone can see it. Or if it's private, it's accessible only from this script. I need my waypoints to be available from other scripts, so I set the access modifier to public. The second word defines the type of value this variable will store. In this case, it will hold an array of prefabs. Each waypoint is a prefab, and prefab is a game object. Square brackets mean it will be an array of game objects. And the last part is whatever I want the variable to be called. So, who can access this variable, what data type it holds, and what name we give it. In C#, we define all variables like this. If I save changes and go back to Unity, on the path game object, inside its custom script component here, I see that waypoints variable. It's an array, so I can click plus to add elements to it. Because of the variable type we defined, you can see these fields expect a value that is of game object type. I go to the prefabs folder, and here we have a waypoint prefab, a pre-configured, prefabricated game object. I will need 5 of them in total, so I drag them one by one into the scene until I have 5 copies. I select the path game object again, and I will drag this first waypoint into the first field in the array, like this. Waypoint 1 game object into this field, and I do the rest. Ideally in the same order, so we have an increasing sequence of numbers that matches the order in the array. This icon is to show and hide gizmos. In Unity, gizmos are visuals that appear in the scene view, but not in the game view. We will use gizmo lines to visualize our path connecting the waypoints, and then we will make enemies move along that path. So let's make sure we have gizmos enabled, and let's open our path script. Unity has a built-in method called onDrawGizmos that we can use to draw visuals in the scene view to help us design or debug our game. If this waypoint array has some elements in it, if the length is more than 0, I create a for loop that will cycle over all the elements in the array. We set the color to gray, and for each of these waypoints inside the waypoints array, we will draw a line connecting them. Unity has a built-in Gizmo's drawLine method that takes the start point and end point, and it will draw a line between these two positions. So I want to start the line at the position of the game object at this index. I access its transform position, and I want to end the line at the position of the next waypoint, so index +1. As we cycle over the array, this index value is increasing by 1, and we are drawing lines between the waypoints. When we reach the last index in the array, there will be no index +1 anymore, so that would give us an error. So I only want to draw these lines until we reach the second to last element. Only draw the lines between this and the next index if the index is the length of the waypoints array -1. Let's save that. You can see a line connecting all our waypoints. Now I can select individual waypoints, and I can use the Move tool to modify my path in any way I want. Maybe I will have some tile map behind, and I will make sure this path matches a road in the artwork that I want the enemies to follow. Notice that because the line is drawn using gizmos, it's visible only in the scene view, but it doesn't render in the game view, which is exactly what we want. I left-click the first waypoint, and I shift-click the last one, selecting all the game objects in between. I will parent all of them under the path game object to keep the hierarchy organized. I can also rename this to Path 1, because we can create multiple different ones in our game later if we want to. With Path 1 selected, I use the Move tool, and I can also move the entire path now, like this. I can select individual waypoints to modify them in any way I need. This technique is extremely useful for tower defense games, racing games, as well as something like MOBAs, such as League of Legends, where you have NPC minions moving automatically along the lanes. You can use the same exact technique we have here for a 3D game as well. Maybe I also want to give the waypoints some labels, so I can easily see at a glance which waypoint corresponds to which game object. Inside OnDraw Gizmos, I can do that here. If we want to define styles for our text in Unity, we can use the built-in GUI style class. GUI stands for Graphical User Interface, and we can use this class to define visual styles, fonts, colors, alignment, and so on. Now I can take that style and I set its normal text color to white. And most importantly, I set alignment to middle center because I want the text to be horizontally centered around each waypoint. I can draw text using handles built in Unity class. We need to include the Unity editor namespace up here to be able to use handles. Handles.label will let us draw a label in the scene view. We pass it 3 parameters. Where we want this label to be drawn, I want it at the position of the waypoint it belongs to, plus 0.7 units above it. The second parameter is what we want the label to say. I will make it display the name of the game object. We can see the names in this field here. And finally, as the third parameter, I apply our custom style we just created. If I save that, you can see we have little labels above each waypoint. In the game view, none of this will be visible. Perfect. Now, let's bring in some enemies and make them walk along this path. Inside Assets Art, I have my sprite sheet, and one of the frames is this simple enemy silhouette. I drag and drop this frame into the scene, and I rename it to Enemy. We can replace it with animated characters later, but first, let's focus on the pathfinding logic. I go to Assets Scripts and create a new folder I call Enemy. Inside, I create a new monobehavior script. I will also call it Enemy. With the enemy game object selected here, I drag and drop the enemy script here as a custom component. I open the script, I delete all this code, and I will define a variable here. I start with serialize field in square brackets like this, and private. The type will be float, which is a decimal number, a number with a fraction part. I will call my variable move speed. I will also give it a default value, for example 3f, f for float. We know we have public variables which are accessible from other scripts, and they are also displayed here in the Unity inspector. Private variables are accessible only from the script, and they don't show up here in the inspector. If I want a private variable, but I want it to display in the inspector, I give it the serialize field attribute, like this. So if I save my changes and I go back to Unity, I can see move speed here, like this, and we see the default value of 3 I gave it. I want another private variable. This time I don't need to see it here in the inspector, so I don't use serialize field. The type is vector3, and I call it target position. Vector3 is a data type that has 3 components. We use it for position, for example, because position needs x, y, and z values. In terms of naming conventions, look at the custom names I'm giving these variables. We will follow .NET style naming conventions here. Public variable names are spelled in Pascal case, where the first letter is capitalized. Private variables will be camel case with an underscore prefix. And my personal choice is that serialize field variable names will be spelled like this, so that Unity can turn them into names that are nice to read in the inspector. These are just conventions. If you don't follow these rules, it will not break your code. But people use them because you can see at a glance what is a public and private variable. Inside the update method, which runs over and over, we want the enemy to move towards the target position. We learned about start and update lifecycle methods. There are many more. For example, we have the onEnable method, which runs every time a game object is activated. Inside, we'll put all the code that I want to run when I reuse this object, because later on, we will learn how to optimize our code for better performance by turning enemies into reusable objects. And every time we reuse the object, every time we activate it, code inside onEnable method will run. When the enemy gets activated, we will give it some target position. For example, just as a test, let's give it a new vector3 and set the position to 4, 0, 0. X, Y, Z. As the update method runs over and over, I want the enemy to move towards that target position. So I set the enemy's transform position to a built-in move towards method. This method expects 3 parameters: current position, target position, and move speed. So I pass it the enemy's current position, where it is right now, and its target position, where I want the enemy to move, and how fast it will move there, which will depend on the move speed property from line 5. I multiply it by time.delta time. Delta time gives us the time in seconds that passed between each call of update. If I account for the actual time passing by like this, we make sure that the enemy moves at a consistent speed on all devices. It's important because the update method might run faster on a more powerful device, but we don't want the device's ability to serve more frames per second to affect how fast things are happening in our game. Accounting for delta time is a very important technique that ensures the speed at which game events happen depends on actual time and not on the frame rate. This is one of the fundamentals of game development and something we have to always make sure we do. Okay, so we have the enemy, a target position of 4, 0, 0. Let's save that and play to see if it worked. We can enter play mode by pressing this play button up here. As you can see, the enemy is moving from wherever it is to the target position of 4, 0, 0 at the speed of 3 units per second. This is position 0, and these little squares are units. The horizontal x position of +4 is 4 units to the right from the middle. 1, 2, 3, 4. I exit play mode. We know our code works. So now, instead of making the enemy move to a position like that, I want the enemy to move from waypoint to waypoint following a path. I select my path 1 game object and I open the path script. To move along the path from waypoint to waypoint, we need a method that will give us the position of a waypoint, depending on an index in the waypoints array. When I call it and I ask what is the position of the element at index 1 in the waypoints array, I want this method to give me x, y, and z position of wherever in the scene we placed this waypoint object. Indexes start from 0, so 0, 1, 2, 3, 4. So this method will expect a parameter of integer type, a number without decimals. I call it index, and it will return the waypoint array at that index we passed to it. It will give us the transform position of that waypoint at that index. So whenever I need to know where to move next, I will call this public getPosition method. To access that getPosition method we just defined from the enemy script, I need a reference to the path1 game object and to its path script component, which contains that method. So serialize field, private, type is path, because I want this variable to hold a reference to this custom path component. And I will call it, for example, current path. Now it's time to learn about another lifecycle method called awake. This method runs once when the script instance is first loaded, same as start, but it runs before onEnable and before start. Inside awake, I take current path and I need to point it from the enemy game object to this path1 game object. And on it, I need to find this path component. There are multiple ways to do that. For example, I call the built-in find method and I pass it the name of the game object I'm looking for. I need to make sure the spelling matches the name of the object I'm looking for exactly. From it, I call getComponent because I'm looking for this path component here. So now, the current path variable holds a reference to this component. We need it because that component has this public getPosition method that we will want to call from the enemy script. Inside onEnable, I set target position to current path, this component, .getPosition, and I pass it index. And depending on the index value I pass it, it will give me the position of one of these waypoints, 0, 1, 2, 3, 4. For example, if I pass it index 3, it would give me the position of this waypoint game object. The reason I had to use awake here is the order of execution. onEnable runs before start, so I couldn't put this line inside start. I had to put it inside awake, because awake runs before onEnable, and I needed this reference to be ready at the point when enable runs. Don't worry about this too much, it will become easy to keep track of the more you work in Unity. You can always have a copy of this chart somewhere and check it when you need it. So if I set this to index 3, I go back to Unity, and I expect enemy will walk from wherever it is right now to the position of this waypoint. I enter play mode and yes, that worked, perfect. Let's try to set index to 0. Save. I expect the enemy to walk to this waypoint. Play mode. Great. We have most of the logic. All I need to do now is to make sure the enemy increases target index by 1 every time it reaches its target position, and that will make it move along the path we defined here. So let's define a private integer I call current waypoint. It will be 0 or 1 or 2, 3 or 4 as the enemy moves along the path and changes targets. Every time we activate or reactivate this enemy, set its target position to be the first waypoint on the path, index 0. As the game runs, we check when the target position was reached and we set a new target position. We need to know the relative distance, how far is the enemy from the target position, the difference between the enemy's current position and its target position. The enemy can be to the right or to the left, so the value can be negative or positive, but we want to disregard that plus or minus. We only want the distance between these two positions. We don't care about the direction. That's why I want the magnitude of the vector. If the enemy is close enough to the waypoint, to its target position, let's say if the distance is less than 0.1 units, we increase the current waypoint value by 1. And we set the enemy's target position to the next waypoint in the path, like this. The enemy will move towards that next target position, and again, when it's close enough to it, it will increase the index again to move towards the next waypoint. I save and play to see if it works. The enemy is moving towards one waypoint after another, following the path we defined. When it reaches the last waypoint, we get an error, so let's fix that. only increase the current waypoint by 1 if we are at an index at least 1 less than the length of the array. Else, we know the enemy reached the end of the path, so we will deactivate the enemy. We set active to false, like this. I save and play. The enemy follows the path, and when it reaches the end, it gets destroyed, it gets grayed out and deactivated. I create an empty game object and I call it spawner. I want to create a game object that will spawn enemies at a specific interval. In the game later, it can be a cave that orcs are coming from or something like that. I reset transform just to make these numbers nicer. No real reason for this otherwise. Inside the assets scripts folder, I create a new monobehavior script I call spawner. Spawner game object selected here, and I attach spawner script as a custom component. I delete all this code, and I define a private float spawn timer and spawn interval. I set it to 1 second by default. Spawn timer will count from 1 second down to 0. It will spawn an enemy and it will count again. So as the update method runs over and over, we are reducing the value of spawn timer by delta time, by real time that is passing by between updates. When spawn timer is less than or equal to 0, we set spawn timer back to spawn interval, which is 1 second right now, and we spawn an enemy. This method doesn't exist yet, so let's write it. Private void spawn enemy. Inside, I create a temporary helper variable. Type will be game object, and I call it spawned object. To create a copy of a game object from a prefab with code, we call the built-in instantiate method. And we pass it the prefab we want to create a copy of. This prefab variable doesn't exist yet, so let's define it. Public game object type, I call prefab, like this. Pascal case, because this is a public variable, so I have to change the spelling here as well. Notice I'm keeping everything generic so that I can set this prefab to be enemy or any other prefab object we will have in the game later, so we can use this spawner class to spawn pretty much anything. It can be very useful. Once we create spawned object from a prefab, we take it and we set its transform position to be the same as transform position of the game object this script is attached to. So the position of spawner game object. Wherever I place this spawner in the scene, that's where game objects will be spawning from. So now I have this prefab field, and whatever prefab I put there, that's what this spawner will start producing copies of. Save that, and in Unity, I see that prefab field here. I go to Assets, Prefabs, and I drag and drop enemy game object in here, turning it into a prefab. I can reset its transform to keep this cleaner. I delete the enemy game object from the scene. Spawner selected, and I drag the enemy prefab into this prefab field. I enter play mode. And enemies start spawning. They start from wherever I placed my spawner game object. They move towards the first waypoint in the path, and they follow the path. When they reach the end of the path, they get deactivated and grayed out here in the hierarchy. As you can see, we keep creating new enemies and deactivating the old enemies. I can also destroy the old enemy game objects completely, but for performance reasons, we want to reuse them instead. So instead of constantly creating and destroying enemy game objects, we want to create a pool of, let's say, 10 enemy game objects. We activate them when we need them, and we deactivate them, returning them back to the object pool instead of destroying them. Object pooling improves performance by reusing inactive objects instead of repeatedly creating and destroying them, which reduces memory allocation and garbage collection overhead. Let me show you a quick and simple object pool logic I like to use for my games. Inside Assets Scripts, I create a new monobehavior script I call Object Pooler. Let's open it. Inside, I delete all this code. I define a private variable I call prefab, what kind of game object we want to store in this pool. For example, this would be the enemy prefab. We will also need pool size, how many of these prefabs we want to pre-instantiate. We want to fill this pool with inactive game objects and activate them when we need them. I will give it a default value of 5, but we can change that later. I will also need a data structure to hold them, private list of game objects. I call, for example, pool. To be able to use list, we need system collections generic namespace up here. Inside the start method, I will create the pool. I assign the pool to a new empty list of game objects first. Then I write a for loop that will cycle over the pool, 5 times in this case. And it will create new game object 5 times. Let's define that method here. Private method that will return a game object. I call it create new object. Helper variable of game object type we call obj. And we already know that to create a game object, we just call the built-in instantiate method, and we pass it the prefab we want to create a copy of. After we create it, we set active to false. We are just preparing some inactive objects into the pool here. We take pool from line 8, we add this new inactive object inside, and we make this method return that object. Let's save that. In Unity, I create a new empty game object I call enemy pool. I reset its transform. Again, our object pooler class is generic, so we can reuse this script to create different object pools in our game. Enemy pool selected, and I attach object pooler script as a component. Prefab field expects a game object that this pool will consist of. I go to Assets Prefabs, and I drag the enemy prefab into this field. The initial pool size is 5 by default, but I can change it if I want to. If I enter play mode, our script automatically creates 5 inactive enemy game objects, but they are all on the top level in hierarchy. I exit play mode. I would prefer if the pooled objects were parented under the enemy pool. In my script, I can pass instantiate an optional second argument that defines a parent. So I pass it transform, but it refers to the game object this script is attached to, in this case enemy pool. So I'm saying set enemy pool as the parent and nest these game objects under it. Inside spawner, I comment out spawn enemy for a while. Save that. Now if I play, start method runs and it creates 5 inactive enemy game objects and it puts them under enemy pool like this, keeping the hierarchy clean. The idea behind object pooling is that when I need a new enemy, I activate one of these, and when I destroy the enemy in-game, I just deactivate it, putting it back into this pool of available objects. Doing this is good for performance, mainly because of automatic garbage collection and memory allocation processes, which can cause our game to slow down if we are constantly creating and destroying new game objects. Object Pooler will need one more thing, a method that will give us one of these inactive game objects when we need it. I will run a for each loop, which will iterate over all game objects in the object pool. We have that pool here on line 8, and as we just saw, it will hold 5 inactive enemy objects. For each loop, we'll check objects in the pool one by one, and when it finds the first inactive one, if active self is false, exclamation mark means false, it will return it, giving us the game object. We are creating 5 game objects initially. Maybe we are in a situation when all of them are being used, and this method will not find any inactive one. In that case, we just create one more and we return it. If needed, we increase the size of the pool, like this. So now, whenever we need a new game object in the spawner, instead of creating a new one, we will call this public getPooledObject method. Inside spawner script, we will not be creating any new game objects here, so I can delete this line. When we spawn an enemy, we want to take the object pool and take one of those inactive game objects in there. I comment this out for a second. I create a variable, type is object pooler, and I call it pool. What is the object pool this spawner will be spawning enemies from? Save that. In Unity, we see that pool field here. And I want to be spawning from this enemy pool. So I drag the game object in here. From it, I can call this getPooledObject method to get one of the enemies from the pool. So when I want to spawn a new enemy, I take the object pool, which we know will be enemy pool in this scene, and we call its public getPooledObject method, which will either give us one of the available game objects, and if there are none available, it will create a new one. Then we do what we did before. We position it wherever in the scene the spawner is, and we activate it. If you remember, when the enemy reaches the last waypoint, it will get deactivated, which will return it back to the pool of available objects. I will also uncomment spawn enemy here. Now if I save changes, spawner selected, move tool, and I will move it somewhere around here. I play, and enemies start coming from the spawner to the first waypoint, and then they will follow from waypoint to waypoint along the path. Notice that if I need more, Object Pooler script will create more, and at some point we have enough, and we will start reusing the old enemy objects. Now we are reusing the same 11 enemy game objects over and over. Throughout the project, I'll be provided source code checkpoints. At each checkpoint, you can download a zip file containing the complete Unity project and source code to open locally. You'll find a link below where you can download all versions of the source code as the project progresses. Right now, we're at the first stage, source code part 1. If you download it, you get access to all the art assets and scripts added to the project so far. To open it in Unity, simply unpack the zip file to a folder on your computer. Then open Unity Hub, click Add Project from Disk, navigate to the folder where you unpacked the project, and select it. Unity may take a few moments to install the required packages. When the project opens, you'll likely see an empty scene. Unity creates an untitled scene by default. To view the actual project, go to the Scenes folder and open the game scene. Now you have the same version of the project I'm working with. You can play it, explore the scripts, and use all the included art assets. Throughout the course, I'll let you know each time we reach a new source code checkpoint. You can then download the next zip file to explore the project at that exact stage of development, if you'd like. Now that we've made sure we are all on the same page and everything is working, let's move on to the next part. We will add multiple enemy types and learn how to use a beginner-friendly, data-driven approach to give each one unique properties and behaviors. When I open my project like this, I see just this empty untitled scene, so I have to go to Assets, Scenes, and open the game scene. In the game window, I go here and change free aspect back to Full HD. I also like to have my game view down here so I can see the scene and the playable version of the game at the same time. Now that you know how to get a Unity project from GitHub and open it locally, let's continue building it out further. I created another sprite sheet. I call it Tower Defense Basic. As always, you can download it in the resources section below. It's pixel art, so after I drag and drop it into my Assets Art folder, with that asset selected, inside the inspector window, I set filter mode to point no filter and compression to none. I click Apply. Up here, I open Sprite Editor. I go to Slice, Grid by Cell Size. I made these frames 100 times 100 pixels. I click Slice and Apply. This is not the final graphics for our game, just placeholder art assets that will represent different enemy types, projectiles, and towers. It will be kind of a grey boxing face. I want to build a complete tower defense game with these placeholders, and then we can choose from many different asset packs to make our game unique. For now, our focus is not on graphics. We'll focus on mechanics, code, and logic, and we'll explain everything in detail to make sure even beginners understand. I want to have different enemy types with different properties. In Assets Prefabs, I rename my enemy prefab to Orc. If I check the enemy pool here, you can see Unity has updated the reference. Orc is shown here, all good. I rename it to Orc Pool. If I check my spawner, it has a renamed Orc Pool here, and if I press play, everything still works. I want to create another enemy type by duplicating my Orc prefab, so I go inside Assets Prefabs, and I copy and paste the Orc prefab. I rename the copy to Dragon. I create another copy and rename it to Kaiju. With the Dragon prefab selected, I lock the inspector, go into the art folder, expand the sprite sheet, and drag the little flying dragon frame into the sprite renderer, into its sprite field. I unlock the inspector, back to prefabs, Orc selected, lock the inspector, and I replace the sprite with the same one from the new sprite sheet, just to keep things consistent. I unlock the inspector, select Kaiju, lock the inspector, and drag the knuckle-walking kaiju monster silhouette into the sprite field. Back to prefabs, and I can now drag out Dragon, Orc, and Kaiju enemy prefabs into the scene. Keep in mind, these are just placeholder assets. We will build this codebase in a generic way so that later you can use your own art and themes. It'll be easy to turn these into robots, aliens, cars, whatever you want your final tower defense theme to be. I just picked Orc, Dragon, and Kaiju to make things a bit more interesting, so we're not working with plain grey boxes. I unlock the inspector. Same as we have a pool of reusable orcs, I need to create one for dragons and kaijus. So I create an empty game object, call it Dragon Pool, reset its transform, add Object Pooler component, and drag the Dragon prefab into the prefab field. I create another empty game object, I call it Kaiju Pool, reset transform, add Object Pooler, and drag the Kaiju prefab into the field. I delete them from the hierarchy. Then I nest all my object pools under the spawner game object to keep the hierarchy clean and organized. I enter play mode and I press pause. I should now have a pool of 5 inactive kaijus, 5 dragons, and 5 orcs. I'm getting a strange error, and when I look in the console, I don't think we did anything wrong. Sometimes Unity can get into an incomplete state and report a random glitch like this. To confirm that it's a glitch and not something we did, I close and reopen the project. Now, if I enter play mode and the error is gone, we know it was nothing to worry about. I exit play mode. Under spawner, now we have our 3 enemy object pools. The way the code works right now, whichever pool we put into this field, that's the enemy type our game will be spawning. So now I'm spawning dragons. And now I'm spawning kaijus. Everything works and no console errors. Perfect. So we have a different prefab for each enemy type, but they all share the same enemy script. Let's open it. We don't need to see this current path field, so I remove the serialize field attribute. To keep it consistent, I rename the current path variable to start with an underscore, indicating that it's private. I'm using Visual Studio Code, where I can double-click current path to select it. Then I tap Ctrl-D or Command-D on Mac to multi-select all occurrences for editing. I select all 5 instances and add an underscore in front, like this. Save that, and now this field disappears from the inspector. I hit play just to test it. Our enemies still follow the path. Good. Inside the enemy script, I'm currently keeping the move speed value directly in the script, I'd like to move this and other values into a scriptable object. This makes game data easier to manage and reuse. Storing values like move speed directly in scripts is called component-driven design, and it's common in beginner-friendly tutorials. But let's structure our project better and use data-driven design. In data-driven design, game logic reads from structured data, like scriptable objects, not from hard-coded values. It's very easy to implement it, and we'll use it throughout this codebase. Let's learn how to handle clean project architecture in a beginner-friendly way. To understand clean data-driven design, we need to understand what a scriptable object is. So let's create one. Inside the Assets folder, I create a new folder called Scriptable Objects. Inside, I right-click, Create, Script in, Scriptable Object Script. And I name it Enemy Data. When I open it, Unity has already generated the basic syntax. We have the Create Assets menu class attribute, which allows us to create new assets from this scriptable object directly in the editor. Let's say each enemy data asset will have a field for lives, which will be a float, damage, which will be an integer, and another float for speed. Save that. Now that we've created the enemy data scriptable object, we can use it to create a data asset for each enemy type. Right-click, Create, Scriptable Objects, Enemy Data. I name it enemy_orc. I give my orc 3 lives, 1 damage, and 3 speed. The same process for enemy dragon. 2 lives, 1 damage, speed of 6. It's going to be faster but weaker enemy. And enemy kaiju will have 10 lives, 2 damage, and speed of 2. Slow but strong. Now I want to associate each data asset with its corresponding prefab. Instead of defining move speed in the script, I want to pull it from the data file. So I define a serialized field, private, enemy data, I call just data for short. Then I delete the old move speed, and in the movement logic, I use data.speed. Each enemy prefab now has a data field. Let's assign the assets. I drag out dragon, kaiju, and orc prefabs into the scene. Select dragon, drag enemy dragon into the data field. Kaiju, assign enemy kaiju. Orc, assign enemy orc. These changes apply only to the instances in the scene, so we go to Overrides, apply all for each one to save the data link to the base prefab. We've now defined a scriptable object class, and using it, we created separate data asset file for each enemy type. These are project assets. They persist outside play mode and between scenes. Great for storing configuration data and avoiding hard coding. Scriptable objects are a key tool in data-driven game development. They let us manage data cleanly, separately from code, and easily inside the Unity editor. Back on the spawner, I set kaiju pool here. I reduce kaiju speed to 1, very slow. And when I play, they spawn and move very slowly. Change speed to 5, and they move much faster. Exit play mode. So instead of storing config in the script, we store it in a reusable asset. Reference it in the inspector and pull data from it, like data.speed. This approach has many benefits, and we will explore more as we build the game. I delete the prefab instances. On spawner, I drag orc pool into the pool field. The spawner now endlessly produces enemy type defined by the pool here. The orc speed is read from the enemy orc data asset. I can tweak it and see immediate changes. Following this pattern, I want to define enemy waves in the same way, with data assets. Each wave defines the enemy type, how many, and how often to spawn. In Scriptable Objects, I right-click, Create, Script in, Scriptable Object Script. Call it Wave Data. I open it and define public float spawn interval, public integer enemies per wave, and we will define enemy type a bit later. Now I can create one. Right-click, Create, Scriptable Objects, Wave Data. I call it Wave 1. I set spawn interval to 1 second and enemies per wave to 3. I also want to define which enemy to spawn in this wave, orc, dragon or kaiju. I could store the prefab asset itself in the data, but since we're using object pools and these pools only exist in the scene, Unity won't allow us to reference them in a persistent data asset. So we need to store a value that lets us associate the wave with a specific pool. To do that, I'll use an enum. Inside the scripts folder, I create a new folder called utils for reusable scripts. Right-click, Create, Scripting, empty C# script. Name it enemy type. Open it, and I change it to an enum. I have a public enum called enemy type, and inside I say orc, dragon, and kaiju, no comma there. An enum is a simple list of names you make to represent different options in your game. The goal is to store a reference to an object pool from which we will be spawning enemies for each wave. We can't directly reference the orc pool, dragon pool, and kaiju pool game objects because they exist only in this one scene. They are not project-wide assets. So instead, we will reference this enum, which will then help our code find the correct object pool in the scene. So each of my waves will have a field for enemy type, this enum, and I call it enemy type, for example. It will be either orc, dragon, or kaiju. If I save this and I go back to Unity, inside Assets Scriptable Objects folder, we created this Wave 1 data asset. You can see this new enemy type field here, and in it, Unity presents the enum as a nice clean drop-down. So Wave 1 will be spawning orcs every 1 second, and it will spawn 3 orcs in total. Great. Now I want to use this wave data scriptable object to create a data asset for the second wave. Right-click, Create, Scriptable Objects, Wave Data, and I name it Wave 2. It will spawn dragons every 0.5 seconds, 6 of them in total. Again, I right-click, Create, Scriptable Objects, Wave Data, and I call it Wave 3. It will spawn kaiju every 2 seconds, 2 in total. Okay, so this is how we define our wave data. The first wave is orcs, the second wave is dragons, and the third wave of enemies will be kaiju. Currently, the spawner only spawns whatever object pool we put into this field. Right now, it's the orc pool. Let's open the spawner script and adjust that logic to work with our new wave data assets. I create a serialized field, private variable, and the data type it will contain will be these wave data assets. This variable will not hold just one, it will hold an array of wave data files. I'll call it, for example, waves. Save that. On the spawner game object, I see this waves list now. From Assets Scriptable Objects folder, I drag and drop the Wave 1 data file. Wave 2, I drop it over the head of the array like this, and it will slot them in order, and Wave 3 as well. We know that each data asset has this enemy type field, where we can choose an enemy type from the drop-down. Those values in that drop-down are defined by this enemy type enum. I need a way to connect these values inside the enum with the actual object pools we have in our scene. We have orc pool, so I create a reference for that here. We also have dragon pool. And finally, a kaiju pool. For now, I put orc pool here on line 26. Save that. The spawner has 3 new fields, so I drag the orc pool game object into this field, dragon pool game object into this field, and kaiju pool will go in here. I enter play mode and I pause my game. We know that as soon as the game starts, these object pools fill with inactive enemy prefabs. Scripts are activating and deactivating them, reusing the same set of enemies over and over, which helps to improve performance of the codebase. We know that the Wave 1 data asset has the enemy type field set to orc, so I want to connect that value to this orc pool field. Wave 2 will be connected to the dragon pool, and Wave 3 to this kaiju pool. The reason why I have to do it like this is because I can't directly reference these object pools in my data files, which would make it easy. But because these 3 object pools exist only in this scene, and these data assets exist in the project across all scenes, Unity doesn't allow me to directly reference non-persistent objects in the data. That's why I have that enum that stores the name of the enemy, and we will now use that enemy name to point to the correct object pool and match the data with scene objects with the object pools. We can do that in many ways. Let's use a dictionary. This is a good use case for it. Let's just write the code and then explain how it works when we see it. Private variable, which will hold a dictionary. We will match enemy type with object pooler. I will call it, for example, pool dictionary, like this. A dictionary is a list of key value pairs. Enemy type will be the key. Object pooler will be the value. The enemy types will be coming from this enum here. Orc, dragon, kaiju. Object pooler values will be coming from these object pools. The goal is to match a keyword from the enum, the names of enemies, with their associated object pools. That way, if I say in this data file that enemy type is dragon, my spawner will know to take enemy objects from this dragon pool. We defined the dictionary here. Inside the awake method, which runs once as soon as the object is created, we will create a new dictionary. I'm saying make a new empty dictionary where I can store enemy poolers, and each one is linked to an enemy type. Inside, I define which enemy type is associated with which object pooler. EnemyType.orc is associated with orc pool, key value pair. If our wave data has the enemy type field with a value of orc, we know that we want this orc pool game object. If enemy type is dragon, we want the dragon pool. If enemy type is kaiju, we want the kaiju pool game object. So now we connected values in our enum with specific object pools, and the link from our data to the pools has been established. We used a dictionary to link each enemy type to its corresponding object pool, so we can quickly access the right pool based on the enemy. Now that we have wave data that tells us what enemy to spawn, how often, and how many of them per wave, I want to be able to cycle over this array of wave data and spawn enemies based on that. We'll need a private integer I call current wave index. Are we currently on wave 0, 1, or 2? Indexes in arrays start from 0, not from 1. We need a way to get data from these wave data assets based on the current wave index. I'll use this syntax. I'll have a property called current wave that, whenever I use it, it will look at this waves list from line 6 and give me the wave data asset at that index, 0, or 1, or 2. This line is a simple getter. It's a read-only property written in shorthand called an expression-bodied property. All we need to know here is that whenever I use current wave in my code, it will give me the data contained in one of these data assets. Which one depends on the current value of this index variable. I save that, and I'll open the wave1 data file just so we can see it. Now I can access these values through the current wave property. For example, this spawn interval will be current wave.spawnInterval. So let's actually use it down here. Whenever we spawn an enemy, we reset the timer back to the spawn interval value so that it can count again towards the next spawn. This orc will spawn every 1 second. We replaced this hard-coded value and I can delete it. We are now using data-driven design in the spawner. We are not storing values here in the script. We are pulling data from these asset files. I save and play to test if it works. We are spawning an orc every 1 second. I can change the spawn interval here, and I can see my game reacts to it. So we know this data is connected to our logic. We have a data-driven enemy spawner. I exit play mode and go back to my code. Down here inside spawner, let's select the spawner game object in Unity so I can see it side by side with my code. Currently, I'm spawning only from the orc pool. Let's spawn from these 3 object pools, depending on what enemy type I set in the data for that particular wave. I say, if pool dictionary, try get value. I put all this code inside. I have to be careful with brackets when I do this. On line 42, I need a reference to one of these 3 object pools. In our enemy data, we have just that enum that says orc, dragon, or kaiju. So I take pool dictionary and I call try get value. This built-in method is a safe way to check if a key has a value. As the key, I pass it the current wave.enemy type, the enemy type held in the currently active wave data file. If that enemy type key has an associated value in the dictionary, we output that and give it a variable name pool. Now I take this pool variable and I use it here. Let's say the current wave is this one, wave 1. I'm saying, do you have a key value pair for orc? If so, give me that orc pool. We matched the orc key with the orc pool value up on line 12. So if current wave changes from this wave to that wave, we'll automatically stop pulling orcs and start using dragons. Current wave index is set to 0 by default, so current wave references this data. I save and play, and we are spawning orcs. I exit play mode. If I change this index to 1, save and play, we will start pulling wave data from this asset file, so the enemies change to dragons. If I change current wave index to 2, current wave is now connected to this data asset. It's also spawning dragons, so I go to Assets, Scriptable Objects, and I open my wave 3 data. I can change the enemy type to kaiju. I play, and we are spawning kaijus. I exit play mode and set the index to 0 as a default. We know that by increasing this index value, we are moving from wave to wave. We connected the enemy type from our data to our code. It defines which object pool we're using. We also connected spawn interval. It defines how often that enemy type spawns. Finally, I want to connect enemies per wave. Once we've spawned this many enemies, we increase current wave index from line 7, and our code will automatically start spawning the next wave. I keep track of how many enemies we've already spawned in this wave using this private float spawn counter variable. As the update method runs, we are counting down using spawn timer. Every time spawn timer reaches 0, we reset it so that it can count again, and we spawn one enemy. I will adjust this condition. Only spawn an enemy if spawn timer reaches 0, and if spawn counter is less than current wave.enemies per wave, the value from here. Else, if spawn counter is more than enemies per wave, we know we've spawned all enemies in that wave and we want to move on to the next wave, current wave index ++, which means increase it by 1. And in this block, every time we spawn an enemy, we increase spawn counter by 1. Let's save and play to test it. The first wave, as we defined, is 3 orcs. 1, 2, 3, and now we get dragons. I set wave 2 to be 6 dragons. After 3 dragons spawn, I get an error, which means I made a mistake in my logic somewhere. When we increase the wave index by 1 and move on to the next wave of enemies, I want to reset spawn counter so that it correctly counts the enemies in the next wave. I save and play. Wave 1 is 3 orcs. Wave 2 is 6 dragons. And then wave 3 comes, 2 kaijus. Then we get an error, which is expected, because we finished spawning wave 3 and we're trying to spawn the next wave, but we only have these 3 enemy waves. I exit play mode, I select spawner game object. Current wave index starts at 0, so we start here spawning orcs. Then, when it's increased, we move on to the dragon wave, then the kaiju wave. And then I want to reset current wave index back to 0, so we start spawning from the orc wave again. We can add as many waves as we want here, and then when we reach the last one, it will cycle back from the beginning again. I can do it by using a single line of code. Instead of using the ++ operator, I can also increase the index by saying current wave index +1. It's the same thing. I'll wrap it in brackets and I use the remainder operator and waves.length. We have an array that has 3 elements. Its length is 3. This line is a clever way to move to the next wave and automatically loop back to the start when you reach the end. The modulo operator, also called remainder operator, makes sure that if the index goes past the last wave, it wraps around back to 0. I'm basically saying, take the current wave index, add 1 using the plus operator, then use the modulo remainder operator to make sure it wraps around to 0 if it reaches the end of the list. The modulo operator is commonly called remainder operator because it returns what's left after division. So when we reach current wave index of 2, the last wave, because indexes are 0, 1, 2, plus 1 is 3, and the remainder of 3 divided by 3 is 0. The index becomes 0, and we start again from current wave index of 0. It can also be written as a normal if-else statement and it will work the same, but I like this clean one-line syntax better. It's just my personal choice. I save and play, and we'll spawn 3 orcs, 6 dragons, 2 kaijus. And again 3 orcs, 6 dragons, 2 kaijus. And again 3 orcs. We have an endlessly repeating enemy wave system. At this point, maybe you'd like to know how to start spawning the next wave only after the previous wave of enemies reached the last waypoint or has been destroyed, as it's usually standard in tower defense games. We can do it by keeping track of enemies we removed. This will count both enemies that reached the last waypoint and enemies that were destroyed by towers. We don't have towers yet in the game, so we will only account for enemies that reach the end for now, and we'll make a small tweak later when we have towers destroying the enemies. In this else-if statement, I add an additional condition. Only go to the next wave if we spawned all enemies per wave, and also all enemies in this wave were removed. So we are inside this update method, and we are counting down over and over. Every time the spawn timer counts down to 0, and as long as we spawned fewer enemies than the enemies per wave defined in our data here, we keep spawning that same enemy type over and over. Else, if we spawned all enemies in the wave and we removed all of them, only then we move on to the next wave. But how do I know that an enemy has been destroyed or reached the last waypoint? How can I detect that in my spawner script? I can use the observer pattern. This is one of the most useful design patterns for game development, and we will learn exactly how to use it right now. The observer pattern is a way to let one object broadcast a message, and the other objects can listen and react when that message is sent. So I will have the enemy broadcast that it reached the last waypoint, and our spawner will be listening for that event, and it will react to it. The advantage is that objects don't need to know about each other directly, they just listen for events. I go to the enemy script. To make an object broadcast a message, we create a public static event. I use the action class. To be able to use it, I need to be using the system namespace up here. This action will carry enemy data with it, so that objects who listen know some information about the enemy in question. And I give it some custom name, for example, onEnemyReachedEnd. We are declaring a public event that other scripts can subscribe to. When triggered, it will send along some information, specifically an enemy data object. The static keyword here means it belongs to the class, not a specific object, so you don't need an instance to use it. The event keyword marks it as something that other scripts can subscribe to and respond when it's triggered. Action enemy data is the type of event, and it takes one parameter, an enemy data object. So I'm setting up a signal called onEnemyReachedEnd that will notify other scripts whenever an enemy finished the path, and I'll give them some information about that enemy. Now I need to find a suitable place in my script where I want to broadcast this message. Inside this code block, we are checking the distance between the enemy's current position and its target waypoint. As the enemy moves along the path, if the path has more waypoints, we travel from one to another. The else block runs when there are no more waypoints, which means the enemy reached the end of the path. Before we deactivate the enemy and send it back to the object pool to be reused later, we will broadcast the event that will notify it reached the last waypoint and is about to be removed from the game. I can invoke the event with this line, onEnemyReachedEnd, ? Invoke data. This shorthand syntax combines null check-in and event invocation in a single line. This question mark says only call this method if it's not null, if it has subscribers. Invoke triggers the event and sends enemy data along as a parameter to all subscribers. The data we are sending along is this variable on line 6, which contains that scriptable object. We created a separate data file for each enemy type that has lives, damage, and speed for each enemy. We are passing that information along as we broadcast the event because it might be useful for the subscribers that are listening to this. We can now react to this event from anywhere in our codebase. I want to react from my spawner script. I need a method that will run as a response to that event being invoked. It will be private, and I will call it, for example, handleEnemyReachedEnd. We know that this event is carrying with it enemy data. I will call it, for example, just data here. We will not make use of it at this point, but later, if the spawner needs to know lives, damage, or speed of the enemy that reached the end, we can read these values from this data parameter. For now, all I want to do here is to increase the variable we called enemies removed by 1. We defined it up here on line 12. Finally, as the last piece of the observer pattern, how do we turn this spawner into a subscriber that is listening and waiting for the enemy to invoke that event? We will do it inside the onEnable method, which runs after awake but before update. I subscribe to it by saying enemy.onEnemyReachedEnd + handleEnemyReachedEnd. I'm simply saying listen and wait for the onEnemyReachedEnd event. Whenever the enemy invokes it, react to it by running the code we put inside handleEnemyReachedEnd, and that's it. So, the observer pattern is a design pattern where one script broadcasts an event and other scripts listen and react when that event happens. Many objects observing one object. We define it like this using static event action keywords. We can invoke it with this syntax, broadcasting the event all over the codebase. If the script is meant to be the observer of this event, we subscribe to that event inside the onEnable method, and we define some method that will run as a reaction. In this case, we are just counting enemies that were removed after reaching the last waypoint along the path. One small thing to finish this, it's a good practice to also unsubscribe from the event inside the onDisable method. Inside onDisable, I do -= here. We do that to prevent potential memory leaks and errors when a disabled or destroyed object is still trying to respond to events. Every time we move on to the next wave, we reset enemies removed back to 0. I save and play to see if it works. There are other ways we could have handled reacting to an enemy reaching the end of the path, for example through a direct method call or the singleton pattern, but the solution we used is probably the best go-to solution that many production-ready indie games use. It's because the way we implemented this decouples the code. Scripts don't need to know about each other directly. This solution also scales well. We can add many more independent scripts that will independently react to this event being broadcasted. As I'm playing my game, you can see we are spawning 3 orcs, 6 dragons, and 2 kaijus over and over, each wave starting only after the previous wave is finished, when all enemies reached the last waypoint and were removed. We are keeping things modular. Each system handles just its job. We will use the observer pattern for many more things in this codebase to really get the muscle memory and get comfortable with it. Because I can read your mind, I know that many of you will ask me in the comments, how do you define a short customizable break between waves? Because maybe you don't want the next wave to come immediately. Maybe you want, let's say, 2 seconds between waves, or even a button that allows the player to click it to release the next wave. I declare a private variable I call time between waves. Let's say 2 seconds as the default value. We will also need a timer that will measure how long we are in between waves. I'll call it wave cooldown. Finally, I need a flag, a boolean called isBetweenWaves. Initially, I set it to false. Inside the update method that runs over and over, I'll create an if-else statement. If isBetweenWaves is true, we will handle some logic. The else block will have all this existing code like this. So if we are in the pause between waves, this code will run. Else, we are not in between waves, so we are spawning enemies as usual. Here, when we finish all enemies in the wave and we increase the current wave index to move on to the next wave, I set the isBetweenWaves flag to true. I save that, and if I play, we get the first wave of 3 orcs. And then we are in between waves and the spawning system pauses. Great. So when we are in between waves, in this code block, we will use the wave cooldown variable as a timer, decreasing it by the real time that is passing by, time.deltaTime. While the spawning is paused, when wave cooldown drops to be less than or equal to 0, I take these 3 lines of code, cut them from here, and paste them in here. I set isBetweenWaves to false, which will make this else block run, spawning enemies in the next wave. Okay, so initially, isBetweenWaves is false, so this else block will run. We are spawning enemies over and over from the first wave until we've spawned and removed all enemies per wave. Then, isBetweenWaves is set to true. This block becomes active. We are not spawning any enemies, we are just counting down wave cooldown. As soon as wave cooldown reaches 0, we move on to the next wave. We set isBetweenWaves to false, and this else block will run, spawning enemies from wave 2. I also need to reset spawn timer. If I set it to the current wave, spawn interval here, the pause between waves will be wave cooldown plus spawn interval. Or I can set it to 0, and the next wave will start spawning immediately when wave cooldown drops to 0. One more thing, every time we go into the pause between waves, we reset the wave cooldown timer back to the time between waves value. Okay, that was a bit of logic, wasn't it? This is one way you can use these 3 helper variables to define a custom pause between waves. If you want a button that you can click to release the next wave, instead of using time between waves and wave cooldown, we create a click event and we tie this isBetweenWaves boolean value to it, flipping it between true or false. Okay, let's see. Yes, I think this logic will do what we want. Let's save that and play to test it. Keep in mind, we set time between waves on line 20 to 2 seconds. I play and spawn the first wave of 3 orcs. As soon as the last orc reaches the end and is removed, a countdown of 2 seconds happens. And only after 2 seconds, we start spawning the next wave, which consists of 6 dragons, one every 0.5 seconds. When the last dragon is removed, we get a 2-second pause, and the third wave starts spawning kaijus. This is a pretty clean way of creating a data-driven enemy wave system. Let me know in the comments if you understood everything so far or if you want to go deeper into this topic. I can make a bonus lesson. For now, let's move on and create some UI elements to display the wave number and player lives. If you downloaded the source code pack, right now we are here. I call this P2 Enemy Waves. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I want to display the currently active wave number. In the hierarchy, I right-click, UI, Text, Text Mesh Pro. Text Mesh Pro is Unity's system for rendering text. The first time you use it in a project, you'll get a pop-up like this, and you click Import TMP Essentials. I rename it to Wave Text. Notice that when I created the text, Unity automatically created a canvas element and the text is nested under it. If I select canvas here and press F on my keyboard to focus it, the camera will zoom out really far because by default, the canvas is large. We can work with it like this because it will overlay itself over the visible game area automatically, and in play mode, it will already work. But I prefer to work with a canvas that is the same size as my camera view. So with canvas selected here, I go to render mode and I select screen space camera. Now we get a field for the camera, so I drag and drop my main camera in here. This will shrink the canvas. And if I zoom in, the canvas is now the same size as the visible game area. I prefer to work with it this way. I rename it to UI canvas. And I go to the canvas scaler component. And in UI scale mode, I set it to scale with screen size. Reference resolution will be the same as this value I have in the aspect ratio field. So 1920 times 1080. Now the canvas and all UI elements we place on it will scale correctly when we play our game on different devices. Notice that when I created the UI text, Unity also automatically created this event system object, which can help us with button clicks, for example. We can just ignore it for now. Just to keep my hierarchy clean, I create an empty game object, I call it managers, and I put it up here. And I nest main camera under it, also global light 2D, and event system. Let's keep these here and focus on the UI canvas now. With wave text selected, I can automatically align it using this anchor presets menu. You can see here it says that if I hold Shift, it will also set the pivot, and if I hold Alt, it will set position. So I will actually hold Shift and Alt at the same time, and I will click this top left corner. This will put the text in the top left corner of the canvas, and it will set its pivot point, its rotation center point, to the top left corner of the text box. You can also see it in here, the text moved to the corner. I move it 50 pixels to the right, and minus 50 here will move it down. I will also increase the width to 400 or 500. By default, it will have some placeholder text that I can set here. We will control this field dynamically with code, so what I put here doesn't really matter. In game view, we can see the text here. Great. In the Assets Scripts folder, I right-click and I create a new monobehavior script. I call it UI Controller. This script will handle the values for UI elements display and also showing and hiding of panels and buttons later. I open it and I will need a variable to access that wave text. Serialize field, because I want it to be visible in the Unity Inspector. Type will be TMP text, spelled like this. For this to work, we need to be using the TM Pro namespace up here. I will call it wave text. We will have a private method I call update wave text. It will take an integer for the current wave as an argument to actually override and replace the text we put into the field earlier. I say wavetext.text. I give it some value. Back in Unity, with wavetext selected, you can see that wavetext.text is referring to this field that we see here. And I'm setting its value to be this hard-coded part that says wave, and a dynamic part with the wave number. Indexes start from 0, but I don't want the first wave to say 0. I want it to start from 1. So let's do current wave plus 1. All right, save that. With UI Canvas selected, I can collapse these components. And I drag and drop the UI controller script to attach it as a component to UI Canvas. You can see the field for wave text here, so I drag and drop it in. We are handling waves inside Spawner, so let's open that script. When we move to the next wave, I want Spawner to broadcast a message. We know from before that to do that, we have to define a public static event using the action keyword, which will work if we are using the system namespace up here. This action will carry with it an integer representing the wave number. I'll call it, for example, onWaveChanged. We will invoke this event inside update. Every time after we update the current wave index and move on to the next wave, if onWaveChanged is not null, invoke it. And it expects an integer, so we pass it current wave index. Okay, every time we move on to the next wave, we will broadcast this message that carries the wave number. I subscribe to it from UI controller, so in the onEnable method. And inside, we subscribe to spawner.onWaveChanged. I say plus equals update wave text. I copy this block, and in the onDisable method, I unsubscribe. So every time we change wave, Spawner invokes an event called onWaveChanged. It carries the current wave index with it. It's an integer. Inside UI controller, we are subscribed to it, and whenever the event is triggered, the update wave text method will run, expecting that integer, giving it a variable name current wave, and using that value to update wave text. If I save and play, the first wave shows just the default text. When the next wave comes, the event is invoked, and wave text updates, telling us we are on wave 2 right now. It works. Will we get wave 3? Yes, great. Then our waves repeat again from the first orc wave. But maybe I don't want this value to go from 1 again. Maybe I want the wave counter to keep increasing. So first of all, I want the wave counter to update and show we are on wave 1 immediately when we enter play mode. Inside the Spawner script, the start method runs once at the beginning of the script's lifecycle. So when we enter play mode, trigger the onWaveChanged event, which will cause UI controller to update wave text and show that we are on wave 1. I save and play. And yes, that worked. I exit play mode. We know that current wave index cycles between 0, 1, and 2 over and over because we have 3 waves here. So we don't want to directly display this value. Let's create a helper variable. An integer I'll call wave counter. Default value will be 0. Every time we move on to the next wave, we increase wave counter by 1. And then we will use that wave counter value here, making the onWaveChanged event carry it with it. I do the same thing here on line 50. Save that. Inside Assets Scriptable Objects folder, Wave 1 data asset, it will be only 2 orcs. Wave 2 will be 2 dragons, and Wave 3 will spawn a kaiju every 1 second, 2 of them in total. Enemy orc will have a speed of 5, Enemy kaiju will have 10 lives and speed of 7. I save and play. Immediately it says wave 1. When dragons spawn, wave counter will show 2. Kaijus come in wave 3. Then we get orcs again, starting from the beginning, but my wave counter keeps counting up, showing wave 4 now, which is exactly what we want. Then, in wave 5, we get dragons, and so on. So this is how we can handle UI updates in a modular, reusable way. I duplicate wave text and rename it to lives text. Let's do the same thing to display player lives in the opposite corner. Every time an enemy manages to reach the last waypoint, the player will lose a life. With lives text selected, I go inside its rect transform component and click Anchor Presets. I hold down Shift and Alt and set the pivot and position to the top right corner of the screen. Down here in the Text Mesh Pro component, I set horizontal alignment to right. Okay, good. I set the horizontal position to -50, moving it to the left, and vertical position to -50, moving it down. This will say lives. In the game view, it looks good. I need a reference to lives text in my script. I duplicate wave text and rename it to lives text. I duplicate update wave text and rename it to update lives text. It will take an integer for current lives. This will say lives, and it will display the current lives value that we passed as an argument to this method. I go to Assets Scripts and create a new monobehavior script. I call it Game Manager. In the hierarchy, I create a new game object and also call it Game Manager. I reset its transform and attach the Game Manager script to it as a component. Here on Game Manager, we will store important information, for example, player lives. It will be an integer. Let's say we start with a default value of 20. All 3 enemy prefabs share the same enemy script, so I'll open it. The player will lose lives when an enemy reaches the last waypoint, which means when it's on enemy reached end, event fires. We are invoking it here on line 41, and it's carrying with it enemy data. That data contains speed, lives, and damage of that enemy. We'll need that damage to determine how many lives the player loses if the enemy reaches the end of the path. Inside Game Manager, we'll have a private method I call handleEnemyReachedEnd. It will expect that enemy data, which I'll call, for example, data. Back in Unity, inside Assets Scriptable Objects, we see that enemy data. For example here, Dragon enemy data has this damage value. So when an enemy reaches the end, this method will run and we reduce player lives from line 5 by data.damage, this value. Some enemies can take more than 1 player life. It depends on what we put in this data. Just to see if it works, I will debug log lives. The enemy is broadcasting an event when it reaches the last waypoint, and Game Manager will subscribe to it inside onEnable. So I say enemy.onEnemyReachedEnd, which is invoked here inside the enemy script on line 41. Notice it's carrying enemy data with it. So here in Game Manager, we subscribe to it, and as a reaction, we call handleEnemyReachedEnd, which expects that enemy data and uses it to determine how many player lives we remove. Same as we did before, it's good practice to always unsubscribe, so I duplicate onEnable, rename it to onDisable, and use -= here to unsubscribe. Save that. And here in enemy org data, let's set damage to 2. Dragon will be 1 damage, and Kaiju will be 3 damage. I save that and I play. To see private fields, I can click here and enable debug mode. And now, on Game Manager, I see player lives here. I can see that each orc reaching the end causes 2 damage. Perfect. Dragons cause 1 damage each. And then we get Kaijus, and they cause 3 damage each. It all works. Lives are not updated here in the UI. To update them, I need Game Manager to broadcast an event whenever anything causes player lives to be lost. And our UI controller will react to that and update the text that displays lives. Inside Game Manager, I create a public static event using the action keyword, and it will carry on an integer value representing the lives. I'll call it, for example, onLivesChanged. We have the action keyword here, so to be able to use it, we need to be using the system namespace up here. Every time player lives change value here, after they receive damage from an enemy, we will invoke onLivesChanged. As the integer parameter, I pass it lives value. We can use this system later for other things that cause changes to player lives. We are building this codebase in a very modular and scalable way. UI controller has this method that will update lives text. Inside onEnable, I make it subscribe to Game Manager.onLivesChanged, and it will react to it by running update lives text. As usual, we also unsubscribe inside onDisable to prevent potential memory leaks. Okay, so inside the enemy script, whenever an enemy reaches the last waypoint, I will broadcast the onEnemyReachedEnd event, passing it the data of the enemy, which contains a damage value, how much damage this enemy causes. Game Manager is subscribed to that event, and as a response, it will trigger handleEnemyReachedEnd. This method expects that enemy data, and it uses it to know how many player lives to remove. Then it broadcasts its own event we defined on line 6, which we called onLivesChanged, and it will carry with it the new updated lives value after we deducted the damage. Finally, we have UI controller, which is subscribed to the onLivesChanged event. Every time Game Manager broadcasts that event, it will react to it by running its update lives text method. This method takes the updated lives value, which I called here, for example, current lives, and it displays that updated value in game. I save that. I disable debug mode here. Inside Game Manager, I create a start method. In here, I also invoke onLivesChanged to make sure the lives UI display updates immediately when the game starts and not only after we lose some lives. Save that. UI canvas selected, and I drag and drop lives text into this field that expects it. If I play, the lives don't update, which means I made a mistake somewhere in my code. I exit play mode. Let's go inside the UI controller script to check the update lives text method. I created it by duplicating this other method, so I forgot to edit this line. I want lives text.text, so I update the value like this. Okay, I save that and I play. We immediately see lives update, showing the maximum of 20 player lives. We know that orcs have a damage of 2, so each one reaching the end will cost 2 player lives. Dragons deal 1 damage each. Let's wait and see. Yes, that works. If we keep going, eventually the lives will go to negative values. Let's say we want to prevent that. One neat way to do that is this line of code. Let's write it and then explain it. Inside Game Manager, inside handleEnemyReachedEnd, we have some incoming enemy damage. And I say, player lives are either 0 or the current lives minus the incoming damage. Whichever of these two options is higher. mathf.max returns the larger of the two values. So, if the incoming damage would take the lives below 0, At that point, 0 will be the higher value and it will show 0. It will show either the current lives value or 0. It will never show a negative value below 0. To test that, let's set the initial lives to 5. Save that and play. Each orc reaching the last waypoint will take 2 lives. Dragons do 1 damage. But as you can see, lives will not go below 0. Our little trick works. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. If I want, I can add more waypoints and make the path more complex. I can do it by taking the last waypoint in my path, and I copy and paste it over and over, creating copies. Now I have 12 waypoints in total. Only waypoints 0 to 4 are connected to the path logic, so to connect the new ones, I select my path1 game object and I lock the inspector. I need to get the new waypoints into this array in a specific order. I can see the last one is waypoint 4 here, so I left-click waypoint 5 here and shift-click waypoint 12, selecting all elements in between. With all of them selected, I can drag and drop them over the header of the array here, and Unity will slot them into the waypoints array in order. I check if they go in the right order, 5, 6, 7, all the way to 12. Now we have new waypoints. They are part of the path logic, and all we have to do is place them in the game world depending on where we want the enemies to walk. Later on, you will have some graphics representing the game world, so these waypoints will be positioned to make sure enemies follow the predefined paths. For now, I will just place them in any way I like. I select the first waypoint, move tool here, and I can move it around. Waypoint 1, move tool, and I want the enemies to go down like this. Waypoint 2 will make enemies move to the right from that point. Waypoint 3, and we will go up, maybe somewhere here. Now we have a bunch of waypoints all on top of each other in the same position, so I will take them one by one and spread them to create whatever path shape I need. Feel free to create any path shape you want now. Waypoint 4 will go to the right like this. Waypoint 5 going down, but only halfway. Waypoint 6 will make the enemies go back to the left for a bit. From there, waypoint 7 will lead them down. Waypoint 8 all the way to the bottom right corner here. Waypoint 9 going up. Waypoint 10 going left again. Maybe the game art will have some obstacles and enemies have to walk like this. Waypoint 11 will go up. And waypoint 12 will be the end of the path, right here. We have a dynamic path that we can modify in any way we want. We have different enemy types that come in waves. We built 2 simple UI elements displaying the current wave and player lives, and we connected all of that together in a modular, data-driven codebase. This is a tower defense game, so the next step is adding the towers. I take spawner and I move it here, to the left of the first waypoint. Inside Assets Art, I expand my sprite sheet and let's pick an image for the first tower type. Let's say this triangle will be my fast shooting basic tower. I drag and drop it into the scene. Unity automatically creates a game object in the hierarchy and I rename it to fast tower. I'm keeping the project generic at this stage, but this fast tower can be turned into medieval archer post or sci-fi drone turret. It all depends on what art style you decide to give to your game. We are just giving it some default simple art assets, and we will keep focusing on game logic and clean and modular code architecture, while still keeping this simple and beginner-friendly. Inside Assets, Scriptable Objects, I create a folder I call Enemy, and I put these 4 files inside. I create another folder I call wave. And let's put all the wave data assets in here. Now I create another folder I call tower. Our towers will also be data driven, and we will store properties for each tower type here. So inside the folder, I right click and I select create, script in, scriptable object script, and I will call it tower data. We are following the same set of steps we did for enemies and waves. I open my code editor. I make sure Unity auto-generated the basic scriptable object syntax here, and I need to decide what kind of properties the towers will have. Public float range, which will define how far it can detect and target enemies. If the enemy enters this range, the tower can shoot or activate its ability. We will also need shoot interval, which will determine how often the tower shoots or activates its special ability. Projectile speed will determine how fast the projectiles move. Projectile duration will determine how long the projectiles exist in the game world before they disappear. Damage is self-explanatory, how much damage the tower causes to enemies. For now, this is enough. I save that. I unlock the inspector. Inside Assets, Scriptable Objects, Tower, I right-click, Create Scriptable Objects, Tower Data. I will call it Fast Tower. My Fast Tower type will have a range of 3 world units. Units are these little squares you can see in the scene view. It will shoot every 1 second. Projectile speed will be 10 world units per second. Projectile duration will be 2 seconds. And if it hits an enemy, it will deal 1 damage. Inside Assets Scripts, I create a folder I call Tower. Inside, I create a new monobehavior script I call Tower. With the Fast Tower game object selected, I drag and drop the tower script, attaching it as a component. Each tower will need a reference to that tower data asset file we just created, so serial as field, private, tower data, I call data. Just a reminder that this attribute allows us to see private variables as fields in the Unity inspector. This keyword defines what data type is held in a variable, and this defines what is my custom name for that variable. Save that. Fast tower selected, and on the tower script component, I see that data field. So I go to Scriptable Objects Tower, I select Fast Tower again, and I connect Fast Tower data with the Fast Tower game object, like this. Now we can access all these properties sitting inside the Fast Tower data asset from inside the tower script. We access it simply by saying data.range or data.damage. Let's try. I want to start by drawing a gizmo to visually represent the tower's range, the area where the tower can detect and target enemies. We used the onDrawGizmos method before to visualize a path by drawing lines between waypoints, so let's use it again here. This time, I want to draw a circle around the tower, representing its range. I do it by saying gizmos.drawWireSphere. It takes 2 parameters, the center point in vector3 format, so I pass it the position of the tower this script is attached to, and the second parameter is the radius of the sphere in a float format. We'll pull that from our data. We set it to 3 here. If I save that, we can see the radius of the tower visualized. If you put your mouse here next to the field, notice it changes the icon, the cursor, and you can hold it down and drag left and right to change the values like this. We can see the wire sphere is reacting to it, so we successfully connected our data. I select the Fast Tower game object. To detect collisions, I add component, Circle Collider 2D. That collider has a radius field here, which determines its size. I can change it like this. The goal is to set this radius value on the collider to always be the same as the range of the tower, to make sure the tower detects enemies that come in range. We will do that with code. So I can set the collider range to any value here. It doesn't matter. I'll set it to 0. Inside the tower script, I need a reference to this collider component, so I declare a private variable. Reference type is Circle Collider 2D, and I call it Circle Collider, like this. Inside the start method, which runs once when the script becomes active, I point my Circle Collider variable to this component using getComponent Circle Collider 2D. On that component, we have this radius field that I want to access now. I access it by saying CircleCollider.radius is equal to data.range. Whatever is the range of the tower, set the collider to that size. Keep in mind that this is the start method. It will happen only once when you enter play mode. If the range of the tower changes during gameplay, we would have to set up the collider radius again. For now, this is good. Save that. Fast tower game object selected here, and I see the radius field here with a value close to 0. I enter play mode, and on the collider, radius field here is 2.79 units, which is the same value I have here in fast tower data. That works. I exit play mode. All our towers will keep a list of enemies. I will call it enemies in range. To be able to use list here, I need the system collections generic namespace, where all the common C# generic data structures live. Inside the start method, I set enemies in range to a new list of enemies. Unity has a built-in method called onTriggerEnter2D, which will run when two colliders interact. For it to work, I save this. The collider has to have this isTrigger checkbox ticked. By ticking this isTrigger checkbox, I'm saying this collider should detect overlaps, but not physically block or push objects. onTriggerEnter2D will only work if at least one collider involved has isTrigger checked. Inside, I want to check if the object this tower's radius collided with is an enemy. I can do that using compare tag, like this. We need to give enemies an enemy tag. Inside Assets Prefabs, I select the Dragon Prefab, and here I go to Tag, Add Tag. In the tags list, I click plus, and my new custom tag will be called Enemy. Save that. Now I can assign Dragon Prefab this new enemy tag. I also do that for Kaiju and for Orc. So if the object that entered this tower's radius has a tag of enemy, I get a reference to that enemy in a temporary helper variable. Type is enemy, I call it enemy, and it will be the object that entered the trigger area. I want the enemy component that's sitting on that object. So this variable holds a reference to the enemy component on the object that entered the tower's trigger area. I want to add this enemy to the list we defined on line 9. I take the enemies in range list, use built-in add method, and I add that enemy to the list. We will also need onTriggerExit2D. If the object that exits the tower's collision radius is an enemy, again I get its enemy component, and if enemies in range contains that specific enemy, I remove it, like this. I need to make sure I spell onTriggerEnter2D correctly, and also onTriggerExit2D spelled like this. I will uninstall my autocomplete plugin, it's doing a really bad job. So we have a tower with a range value. We set its circle collider to the same size. When an enemy object enters the collision area of the tower, we add it to the enemies in range list. If it exits the area, we remove it from the list. Now the tower will always be aware of all enemies that are within its range. Save that. Enemies in range is private, so to be able to see that field here, I need to enable debug mode. Here. I enter play mode. The enemies in range list is here, and it stays empty, so I know we forgot something. We're trying to detect collisions, but for any collision event like onTriggerEnter2D to be called, at least one of the two game objects involved must have rigid body 2D component. I select the Dragon prefab. I disable debug mode here. Down here, I add component, rigid body 2D, and I set it to kinematic. By doing that, I'm saying don't apply forces, gravity, or physics to this object. A kinematic rigid body will not move unless we move it with code. I want enemies and towers to be able to detect each other, but I don't want any pushing around. I also add rigid body 2D to kaiju, and I set body type to kinematic. And I do the same for orc enemy prefab. Add it and set it to kinematic. I select Dragon again, add component, Circle Collider 2D. If I double-click the prefab, we'll see it like this, and I can set the radius to 0.3, maybe 0.4. I make it a little bit easier for towers to hit these small, fast dragons. Kaiju selected by double-clicking on it to enter the prefab. Add component, Circle Collider 2D. This radius seems fine. I double-click Orc prefab to get this view. Unity has colliders of different shapes, so maybe we can use Capsule Collider 2D here instead. I keep direction as vertical, and I squeeze it from the sides by setting X to 0.6, maybe 0.9 vertically. Sometimes this is useful if you want a collider shape that matches the enemy shape more closely. If I press this arrow, we get one level up into the scene. I made sure that all three enemy prefabs have kinematic rigid body 2D and some kind of a 2D collider. I play, I enable debug mode, and with fast tower selected, I can see its private enemies in range list, and I see that enemies get added and removed from that list as they move in and out of the tower's range. We see the tower's range here as this circle. Let's wait for the next wave of dragons, and yes, it detects them when in range. Perfect. We added an important piece to our tower defense logic. We have a tower that has a range property, and it is aware of all enemies that are within that range. We can do so many things with this. For example, we can make the tower aim at enemies and shoot projectiles in their direction. Let's do that now. Inside Assets Art, I have this placeholder sprite sheet with some basic simple art assets. Let's use this one, for example, as a projectile. I drag it into the scene, zoom in a bit, I rename it to projectile. If I go to main camera game object, here inside its camera component, background color field, I can change the background color to anything I want. I'll just choose a random color, it doesn't really matter at this point. I guess something not too light, but also not too dark, because the enemy silhouettes are black. With projectile game object selected, I disable debug mode. Let's go back to normal. I add component, Circle Collider 2D. I need to make it much smaller, maybe radius of 0.2 or 0.15. I add component, rigid body 2D. I set it to kinematic. In scripts tower folder, I create a new monobehavior script. I call it projectile. I attach it as a component to projectile game object. I open the script and I delete all this code. I will leave only the update method. Inside the tower script, my towers will need a reference to an object pooler holding all their projectiles. Each tower will have its own small object pool, reusing the same projectiles over and over, making our code more performance efficient. Because of the fact that I will add that object pooler component directly on the tower, I can simply reference it here using getComponent. I'm saying find object pooler component on this game object attached to this tower script. Save that. I go inside Assets Prefabs, and I drag and drop projectile game object, turning it into a prefab. I can delete it from the hierarchy now. I select Fast Tower game object, and I add component. Object pooler. Fast Tower will have its own pool of 5 projectiles. If I play, Fast Tower will have those 5 inactive projectiles nested under it, like this. Each of the towers will be storing its own small set of reusable projectiles. Tower will need a method that will aim at an enemy and produce a projectile in that direction. I will call it shoot. When shoot is called, first we will check if the tower still has any enemies in range. Enemies in range is a list, and if its count is more than 0, we will actually do something. First, we need to get a free available projectile from the object pool. Projectile pool, which is referencing this object pooler component, and we call its getPooledObject method, which will look if there is a free inactive and available projectile, and if not, if all 5 are being used, it will create a 6th one, for example, and it will give it to us. We are storing it in a temporary helper variable I called projectile. I take that projectile and I set its transform position to the same position of the tower, because if we are reusing the projectile, it might have flown off screen in the previous active cycle. Then we activate the projectile. The projectile will need to know which direction it should move away from the tower. The direction will be the relative distance between the position of the tower and the position of the first enemy in enemies in range list. By doing this, this tower will always target the first enemy that entered its range. Here we are dealing with vectors. Each of these values has x and y components. This line calculates the direction vector from the tower to the first enemy in range, and then it normalizes it. By normalizing the vector, we make its length, its magnitude 1, but we keep its original direction. That way, it only contains directional information and not distance, and we can multiply it by a speed value to move the projectile in that correct direction at any speed we want. If you've never dealt with vectors, don't worry about it too much. We will talk more about this later. Save that. Let's look at the projectile prefab, and let's open projectile script. Projectile will have a public method I call shoot. Back inside the tower script, we take that projectile, it's referencing this entire game object, and I want the projectile script component, so I say getComponent projectile. And from it, we call the shoot method we just defined. I pass it data. Up here on line 6, we have that tower data, which contains current stats of the tower, for example, its range and projectile speed. I will pass a reference to that entire data object to the projectile's shoot method. I will also pass it the shoot direction we just calculated. Okay, so shoot method of the projectile is called, and it's receiving tower data and shoot direction. We defined that method here inside the projectile script, and I make sure it expects those arguments. Tower data type, we call data. Vector3 type, we call shoot direction. I want to have these 2 values available outside shoot method as well, so I will create properties that will store them up here. Data and shoot direction, like this. I will also store projectile duration as a separate float property. When the shoot method gets called and receives these values from the tower that shot this projectile, this method will take those incoming values and assign this data to the data, shoot direction to the shoot direction property, and projectile duration from line 7 will be coming as a part of the incoming data. And I get it from there like this. This tower data we are referencing up here. Save that, and in Unity, I go to Scriptable Objects, Tower, Fast Tower. Here we see all the data it contains. So this tower data is being passed to the projectile when the tower shoots. And here we are accessing, for example, this data.projectile duration. In this case, it's 2 seconds. I might refactor this a little bit later, but for now, the projectile knows everything it needs. So inside the update method that runs over and over while the projectile is active, we say, if projectile duration is less or equal to 0, deactivate it. Game object set active, false. Else, meaning that projectile duration is more than 0, we are decreasing projectile duration by the real time that is passing, time.deltaTime, and we are moving the projectile using the shoot direction value we received from the tower. We received it here inside the shoot method. We saved it as a property on line 6, and from there we can use it inside this update method. So I use its horizontal and vertical component. Keep in mind we normalized this vector, meaning its magnitude is 1, and now I can scale that vector times projectile speed, making it move in the right direction at whatever speed is coming from the tower data. We will also account for time.deltaTime to make sure this movement happens at the same speed on any device, regardless of frame rate. We always want to time events in our game based on real time, not based on frame rate. This is a very simple example of a data-driven architecture. The code always remains the same, while the behavior dynamically changes based on the input data. For example, a fast tower, maybe it's an archer tower, may define a high projectile speed, resulting in quick shots, whereas a slower tower, let's say a ballista post with slow projectile speed, will still function correctly using the same logic. This decoupling of logic from data lets us build flexible and scalable tower configurations without modifying the underlying code. In short, the same code we have here will work for multiple different tower types by just changing the input data. Okay, so when the tower shoots, we get a projectile from its pool. We set its position over the tower and we activate it. We calculate shoot direction from the tower to the enemy and we call shoot method on the projectile, passing it tower data and shoot direction. On the projectile, we save those values as properties, and we use them inside its update method to move the projectile in that direction until its duration runs out. Then we deactivate it, returning it back to the pool of available objects. So when do we actually call this shoot method on the tower? We want to do it periodically based on the shoot interval value we put inside tower data. For example, I set fast tower to shoot every 1 second here. We will need a helper property I call shoot timer. We will use it as a countdown. In the beginning, I set shoot timer to data.shootInterval. So when the tower is placed, we will wait 1 second before it shoots. Update method will run over and over. Here we set shoot timer to 1 second. We will be counting down using delta time as usual. As soon as shoot timer drops to be less or equal to 0, we reset shoot timer back to data.shootInterval to count towards the next attack, and we trigger the tower's shoot method. So this is how you can trigger something periodically to repeat over and over. Again, we are using data here to define how often the tower shoots. So if we plug in a slow shooting tower here, this code will work with that tower type as well. All we have to change is the data file we associate with this tower script. So every 1 second, this shoot method from line 59 will be triggered, producing a new projectile, activating it, and giving it direction. This method here on the projectile will run, and this code will update the data. And while the projectile is active, this update method will run over and over, moving it in that direction. I save that and I play. The tower is shooting in the direction of enemies in range, and projectiles are too slow, so they miss, but everything is working exactly as we need it. I exit play mode. I go to Scriptable Objects, Enemy folder, and Orc Enemy will have speed of 2. Kaiju will be very slow, speed of 1. Dragon is a small and faster enemy, speed 3. Now if we play, the towers are managing to get the projectiles much closer to the enemies. Later on, we can introduce a projectile that can actually seek out enemies and always hit, But this basic fast tower type can miss, and it will be a key part of the game loop, where knowing where the enemies come from and positioning towers strategically is important to win. Now let's make projectiles and enemies actually register collisions. In the prefabs folder, projectile prefab selected, I find its circle collider component and I check its trigger. Then I go in the projectile script and I define onTriggerEnterToD method. Inside, I check if the thing we collided with is an enemy, and if it is, I need a reference to its enemy script. So I do getComponentEnemy, like this. In Unity, let's have a look at one of the enemies, for example, the dragon prefab. It has a tag of enemy here, and I want to access this enemy script component. I need that script because it will have a public takeDamage method that will accept a damage value from the projectile coming from data.damage in the tower data that we passed via the shoot method. Once the projectile hits an enemy, I want to deactivate the projectile. This method doesn't exist yet, so let's write it. I open the enemy script and I define public void takeDamage method. It will take that incoming damage value and its float, and I will call it, for example, just damage. In my scriptable objects, for example here, I see that the enemy dragon will have 2 lives. Inside the enemy script, I create a private float I call lives. Inside onEnable, whenever we activate the enemy, we set lives to data.lives. So basically this is the enemy's current lives, and in the data we keep its max lives. Enemy is a pooled object. Every time we reactivate the enemy from the pool, we reset its lives to the maximum, in case it lost some lives in a previous active cycle. Whenever the enemy takes damage, I reduce enemy lives by the incoming damage. Maybe we don't want the lives to ever go below 0. So after that, I can again set lives to either the current value or 0, whichever is larger. If enemy's lives are less or equal to 0, we deactivate the enemy. Save that, and if I play, tower is hitting orc, and it will get deactivated. Let's pause here. The active orc enemy selected. I enable debug mode, and I can see it has 1 life. Okay, I unpause the game. Let's go back to normal. And if I play, as you can see, there is no second wave coming. We have to adjust the spawner a little bit now that towers can destroy enemies. I exit play mode. I open the spawner script. We are keeping track of enemies removed here to determine whether all the enemies of the current wave have been dealt with, and we can move on to the next wave. I need to make sure that this enemies removed value accounts for both enemies that reached the last waypoint and enemies that were destroyed by towers. Inside the enemy script, I will create another event. I will call it onEnemyDestroyed. And this time, it will not carry enemy data. It will have a reference to the entire enemy object. When enemy lives drop below 0, before we deactivate it, we will invoke onEnemyDestroyed event. I will pass it this keyword, passing it a reference to the enemy that was destroyed, the object that is running this code. Inside the spawner, we need a method that will run as a reaction to this event. I will call it handleEnemyDestroyed. We know the argument here is type enemy. I will call it, for example, enemy. For now, we will not use it. We will simply increase enemies removed by 1. Notice that in both of these cases, when the enemy reaches the end and when the enemy is destroyed, we are increasing the same enemies removed variable here and here. Up here on line 41, we subscribe to onEnemyDestroyed event with this new handleEnemyDestroyed method. And we will also remember to unsubscribe here inside on disable. So up here, we have enemies removed. Only when all enemies of this current wave spawned and the same amount of enemies were removed, we move on to the next wave. Save that, and on the main camera, I change background color to something else. I can also select my projectile prefab and use this color field to change its color. Okay, I click this arrow to go back. Let's make the main camera actually lighter. Enemies are dark, so they won't be visible with such a dark background. And on the projectile prefab, I make the color darker. I just want a bit more contrast so that we can see the projectile against the background. This is all just placeholder art anyway. Let's play it to test it. The first orc is destroyed by the tower. The second orc is destroyed, so we have no more enemies. So after a 2-second cooldown, we get Dragon Wave. Tower managed to destroy one dragon, and the other is out of range now. It works, perfect. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. We are almost done with the tower setup. We just need to make sure towers update their enemies in range list as the enemies get destroyed. Inside the tower CS script, I create a private void method I call handle enemy destroyed. It will take the enemy that was destroyed as a parameter. It will take the enemies in range list and remove the enemy that was just destroyed. The enemy script has this public action called onEnemyDestroyed. When an enemy takes damage and its lives are less than or equal to 0, it invokes this event. The tower will subscribe to that event inside the onEnable method, like this, and it will react to it by running the code inside the handleEnemyDestroyed method. Inside onDisable, we unsubscribe, as usual. And handleEnemyDestroyed will remove that enemy from the enemies in range list, so the tower will stop attacking it. I take the fast tower game object and drop it into Assets Prefabs folder, turning it into a prefab. Now I can drag the prefab into the scene as many times as I want, creating multiple fast towers. Each one of those towers will keep its own enemies in range list, keeping track of enemies that are within its range. Now that we have the towers that can destroy enemies, I want to give enemies health bars to see how much damage the towers are doing. I drag and drop the health bar image into the Assets Art folder. It's just a simple white rectangle. You can download all project resources in the description down below. With the image selected, I set sprite mode to single and I apply. I drag and drop it into the scene. I go to Assets Prefabs and I drag the orc prefab into the scene. I delete this fast tower so we have some space here. I drag out the dragon prefab and the kaiju enemy prefab here. I rename the health bar to start with a capital letter. I drag it over the orc like this to nest it under it. I copy the health bar by pressing Ctrl-C or Command-C on Mac, and back on the top level I paste it by Ctrl-V or Command-V. I nest it under kaiju. Again, on the top level I paste it, and this copy will be nested under dragon. Orc health bar selected, and I set it to 0, 0. I move it up vertically, maybe plus 0.6. Dragon health bar, 0 horizontally, plus 0.5 vertically, moving it above the head of the dragon. Kaiju health bar selected. X is 0, Y is plus 0.6 or 0.55. Inside the enemy script, each enemy has lives here on line 14. We want to project that value onto the health bar and change the width of the health bar based on the current value of lives. This is a very common thing you might want to do in many different kinds of games. Let me show you a simple way I like to do it. First, we will need a reference to the health bar itself. I need access only to its transform component, this bit here. So let's set type to transform. What type I use here depends on how I plan to interact with the health bar. If I wanted to disable the health bar, access its components, or interact with the full object in some way, I would use GameObject type here to have a reference to the whole thing. In this case, we care only about positioning, rotation, or scaling, so we will use transform. You'll notice this is a very common way to do it in many different types of games, if you want to resize the health bar based on the unit's current health. If I save, orc selected, we have this new health bar field, so I drag and drop orc's health bar into this field. You can see this little plus here. It means that this single copy of a prefab has some changes on it that are not applied to the base prefab. Sometimes we want that, but in this case I want all the changes I made to this orc to be on the base prefab, so that all the future copies of the orc prefab have the health bar on them. When we instantiate a prefab in a scene and then change some of its properties, Unity tracks those changes as overrides. This plus means this object is no longer exactly like the original prefab. We have made changes to some parts of it. If I go to overrides here, I can see we made changes to the enemy script and we added a health bar. Now I want to select Apply All. It will push all the changes back to the original prefab, and all prefab instances will reflect those changes. All orc prefabs will have a health bar. Dragon instance selected here. I drag Dragon's health bar into the field here. Then I go to Overrides and Apply All to apply all these changes to the base prefab as well. I select Kaiju, I drag its health bar here, and I apply all overrides. I want the health bar to scale down as the enemy loses lives. We will need to keep its original size in memory. It will be a vector 3 I call health bar original scale, like this. The awake method runs once on each script when its game object appears in the scene before anything else happens. Inside, we save the original size of the health bar. Original scale is equal to healthbar.localScale. I create a private method I call updateHealthBar. A helper variable I call health%. It will be equal to the enemy's current lives divided by its max lives. We are storing max potential lives for each enemy inside its data. One more helper variable I call scale. It's equal to healthbar original scale. It's a vector 3, so it has x, y, and z components. We want to scale the health bar horizontally, so we only care about scale.x, its horizontal component. It will be the original horizontal scale value multiplied by health%. And then we set the local scale on the health bar to that scale with the modified x component, like this. So we are taking the horizontal component of the health bar's vector 3 scale value, multiplying it by the ratio between the current lives and max lives, and setting the health bar to that updated scale value. Now we just have to call this updateHealthBar method every time the enemy's lives value changes, right here. And also up here inside the onEnable method. The enemy is a reusable pooled object, so when we reuse the enemy and reset its lives, we want to make sure the health bar resizes as well. I save my changes. I delete all these because we apply the changes to their base prefabs. Let's drag out one more tower and place it here. It works. The enemy health bar is shrinking horizontally when enemies lose lives. This might be what you want, but let's say we want the health bar to shrink to the left, which is probably the most common way to do it. I exit play mode. Inside the art folder, health bar image selected, I open sprite editor. This is its pivot point here, and I can change its position in this drop-down. I set it to left center, moving it here. I apply changes and close sprite editor. In prefabs, I can see it moved the health bars to the right, which was expected. I double-click the dragon prefab to get to this view. The health bar is sitting here, nested under the enemy. I set its horizontal position to -0.5 to center it. This works because health bars are exactly 1 unit wide. If you are using different sizes, you might have to play with this to figure out the right offset value here. I double-click Kaiju to get this view. I select the health bar and again set -0.5 as the horizontal offset. And I do the same for the health bar on the orc enemy. This arrow will take me back to the full scene view, and I enter play mode. Now we get health bars that shrink to the left, the most common way to do it, I guess. I move the towers around a bit so that each tower covers its own area. It doesn't really matter at this point. Currently, we have 3 waves of enemies that repeat over and over. What if I want the enemies to slowly get more health every time a new wave spawns, creating a simple difficulty curve? How would we implement that in a way that works with our data and with health bars? It's actually pretty easy. I create a public method I call initialize. It will take a float parameter for health multiplier. The point of data-driven code is to separate static configuration from runtime logic. That means values that don't change, like initial lives or settings, are stored in scriptable objects. Changing values, like the current number of lives during gameplay, should be stored in regular class properties or components. Every time initialize runs, we want to reset the enemy's current lives to the maximum value. So current lives of the enemy are the base max lives from the data times the health multiplier. As the waves come, the health multiplier will be increasing the total health enemies have over time. And as usual, we want to update the health bar to reflect these changes. Inside onEnable, I delete these 2 lines of code. We will handle this inside the spawner script instead. So I save, and I open the spawner script. I want to do that here because we will calculate the health multiplier based on the current value of the wave counter. As the wave counter increases, enemies will be spawning with more and more health. Health multiplier is something we multiply base enemy lives by, so it will always be at least 1, the base value, plus wave counter value times 0.1. As wave counter increases, enemies' health will be increasing by 10% per wave. You can change this value here if you want to make enemies gain health at a different rate. Wave 1 will be 1.1, so 110% of base health. Wave 2 will be 2 times 0.1, so 1.2, 120% of the base health, and so on. Now I need access to the enemy script component on the enemy we just spawned. We are inside the spawn enemy method. I know the spawned object is an enemy, so get component enemy. I need that component because I want to access this initialize method we wrote on line 74. So let's call it here. And we pass it the health multiplier. This method will increase the maximum health of the enemy we just spawned based on the current value of wave counter, because we are passing it this health multiplier from line 95. Save that. I go to Scriptable Objects Enemies folder, and enemy orc has 3 lives. enemy dragon has 2 lives, and enemy kaiju has 10 lives. Those are the default base max lives values. I enter play mode, and waves are increasing. Dragon wave finished, so now kaijus are coming. We know that their base lives is 10, and tower projectiles do 1 damage, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Enemy health is already scaling. At some point you'll see that health bars grow noticeably. Like this. We don't want that. We want the health bars to never go over the maximum width, and if enemies get more health, the health bar will stay the same width, it will just fit more lives into that space. The issue is that here, the health percent ratio is using the fixed value of data.lives. We don't want to modify max health inside our data files, so let's hold that ever-increasing max lives value as a property up here. Private float max lives. Initially, this is max lives from the data, but as soon as wave number starts increasing, max lives value will be increasing by 10% per wave. So let's calculate max lives here instead, like this. Then, as we spawn an enemy, we reset its current lives to the increased max lives. And the health percent here, the value by which we scale the horizontal component of the health bar, will be the ratio between the enemy's current lives and those updating ever-increasing max lives. This will keep the health bar at the same width, fitting this increased lives amount into that same space. I start, and orcs have 3 lives. 1, 2, 3. Dragons have slightly over 2 lives, but not yet 3, as we increase the health by 10% per wave. Now we have kaijus, and we can see that if enemies have more lives, the health bar just shrinks by smaller chunks as they get hit. Then we get orcs again. The health bar is no longer too wide. We know that orcs start on 3 health, but if I count the hits, 1, 2, 3, 4. Our health scaling works, and the health bar doesn't go over its maximum width. In tower defense games, it's quite common to scale enemies' health like this to make sure the game stays engaging and doesn't become trivial as we build more towers, which would quickly overpower the basic weak enemies. Also, you can use this health scaling technique for many other games. I hope you are getting some value and learning new game development tricks. We have a way to defeat enemies. Now we need those enemies to reward some kind of a resource or currency that we will use to buy more towers or to upgrade our existing ones. I start by going inside Scriptable Objects enemy, and I open the enemy data script. I want to add a field with a float value for resource reward, how many resources we get when our towers destroy this enemy. Save that. And now each of those scriptable objects has a new resource reward field. So orc will reward 1 resource point, dragon will reward 2 points, and kaiju will give us 3 points. We will store and manage resources on Game Manager. I can close all these tabs. It will be an integer I call resources, and initially I set it to 0. I create a private method I call addResources. It will take an integer for amount, and inside we will increment the current resources value by the incoming amount. The amount will depend on which enemy was destroyed and what its resource reward value was. Let's open enemy script. For now, the only event that will give us resources is when an enemy gets destroyed by one of our towers, when this onEnemyDestroyed event is invoked. Notice that it carries with it a reference to the entire enemy component. And when we invoke it here, we pass it this keyword. I need access to the enemy data we have here on line 6. because that's where we store resource reward values for each enemy type. So let's turn it into public read-only property. Public enemy data, data, fat arrow data, like this. We define a public property called data with capital D, and we are setting it equal to the value of the private field data from line 6. What I did on this line is a shorthand syntax. It's called expression-bodied syntax, and it's used to define read-only properties in C#. I could have also spelled this line like this, in a longer form. It would be the same. So this line is a public read-only way to access the private data field from outside the class. I do that because when onEnemyDestroyed runs, it carries with it a reference to this entire enemy class, and from it, we will be able to access this public data field to check how many resources this enemy rewards. Inside Game Manager, we will have a private method I call handleEnemyDestroyed. It will take that enemy reference as a parameter. Inside, we call addResources, which we defined here on line 37. And as the amount, we pass it the enemy that was passed here. .data, and on it, we get resource reward. So data is coming here from line 7, and we know each enemy data asset has a value for resource reward. Notice that resource reward in the data is defined as a float, but addResources expects the amount as an integer. So let's convert this value to an integer. Okay, so when we call handleEnemyDestroyed, it calls addResources and passes it whatever resource reward that enemy gives. The addResources method then adds that amount to our resources total. Now we want to run this method whenever the onEnemyDestroyed event gets invoked. So up here inside Game Manager, we subscribe to onEnemyDestroyed, and as a reaction, we will run the handleEnemyDestroyed method we just wrote. As usual, we will also remember to unsubscribe here. Save that, Game Manager selected, and I activate debug mode so we can see the hidden private resources field here. I play, and as we destroy orcs, we are getting resources. So let's create a UI element that will show the current resources amount to the player. I exit play mode and I go back to normal mode. Let's expand UI canvas. I copy and paste lives text to duplicate it. I rename the copy to resources text. I set its horizontal alignment to center. Default text will say something like resources. It doesn't really matter, we will override this value with code immediately as the game starts. I click here on Anchor Presets. I hold down Shift and Alt, and I choose Center Top Alignment here. I move it -50 pixels vertically to give it some space from the top. Yes, this looks good. I open UI controller script. I will need a reference to this resources text field, same as we did for wave text and lives text before. I copy this method and I rename the duplicate to update resources text. It will take an integer for current resources. Inside, I set resources text.text to a static part that says resources, plus a dynamic part with the current resources value. We have a function that will update the resources text. When will we run it? On Game Manager, I create a new public event that will carry with it an integer, and I call it, for example, onResourcesChanged. Whenever we add resources, we invoke onResourcesChanged, and we pass it the updated resources value. On UI controller, we wrote this method that will update the resources display in our UI. Up here, we will subscribe to GameManager.onResourcesChanged event, and as a reaction, we will run update resources text. And we also remember to unsubscribe down here. Save that. UI canvas selected, I see the new resources text field here, so I drag and drop resources text inside. Inside Game Manager, I also want to invoke onResourcesChanged event inside the start method when the game starts. Save that and play. Resources text will update immediately, showing 0. And as we destroy enemies, we are getting resources. We will spend these resources to buy new towers. We will be able to choose from multiple different types of towers, so we will need a UI panel that will display that selection of towers for us. But before we do that, let's create a game background and add more tower types for player to choose from. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Our game will have just the generic placeholder visuals. I want to build a fully functioning game that we can turn into different art styles. I drag and drop the Path1 image into the Assets Art folder. I put together an image where arrows point from waypoint to waypoint, showing where enemies will go. You don't have to do this part with the background, it's not that important. But if you want to, you can download the image in the resources section below. I set the sprite mode to single, mesh type to full rect, because this image has transparent parts. This will make sizing and positioning the image easier. I also set filter mode to point no filter and compression to none. Settings we use for pixel art. It doesn't really matter here, it's just a placeholder image anyway. I click apply, I expand the sprite and it has only one frame now. I drag and drop it into the scene. I rename it to background. I reset the transform here. I scale it down horizontally and also vertically. I just want these arrows indicating how the waypoints follow one after another. Enemies will follow these arrows. I also added some spider webs in the corners just for fun. You probably have your waypoints set up in a different shape. Your path is probably different. That's why I said this part is optional. Having this image here is not that important for anything we will do next. I'm just playing a bit now. But if you want to have it and you want to use this image, you can always move your waypoints and make them create the same path shape I have here. Or you can create your own image. It's entirely up to you. We have this background image. We have towers and enemies in our game. Unity will decide kind of randomly what is rendered in front and what is behind. We want to be able to specify the draw order in our game. On the background game object or on any of the fast towers, I find the sorting layer field and I click Add Sorting Layer. This will take me to the Tags and Layers tab. Right now, everything in our game is on the default sorting layer. I click the plus icon here 4 times and we will have 4 custom sorting layers: background, towers, enemies, and UI. This order matters. Background will be all the way in the back, behind towers and enemies. Objects on the UI layer will be all the way in front of everything else. My background game object will go on the background sorting layer like this. I will drag the background here under managers to hide it. Let's keep the hierarchy clean. Inside the prefabs folder, for the waypoint prefab, I set its sorting layer to background. But the order in layer will be 1, above the background image. The fast tower prefab will be sitting on the towers sorting layer. The projectile will also be on the towers layer, but in front of the towers, so order in layer 1. The dragon prefab will be on the enemies layer. Enemies will be in front of the towers for now, to keep it simple. I also double-click the prefab to get this view. I select the health bar, and I set it to the enemies sorting layer, order in layer 1. Kaiju will also be on the enemies sorting layer. Select health bar, enemies layer, order in layer 1. And I do exactly the same thing for the orc prefab. I click this arrow to go back to the regular scene view. UI elements, buttons, panels, and status text are all drawn on the UI canvas, so I set the UI canvas to the UI sorting layer, like this. UI will be in front, on top of everything else. I enter play mode, I have the background all the way in the back, towers in front of it, enemies in front of towers, and UI elements in front of everything. We are building this game as a data-driven code base, which means that the code that handles towers will stay the same, and we can create different types of towers by creating different data assets with different values. Just doing that will dramatically change what the towers look like and how they interact with enemies. Let me show you exactly what I mean. We will create 3 different types of towers, each with its own strengths and weaknesses. Inside Assets Scriptable Objects Tower, we have the Fast Tower data asset. I want this tower to have a range of 3.5 units. It will shoot a projectile every 0.7 seconds. Projectile speed will be 10 units per second. Projectile duration is 2 seconds. And if it hits an enemy, it deals 1 damage. I duplicate the Fast Tower data asset by copy and pasting it here, like this. I rename the duplicate Burst Tower. This tower will shoot swarms of fast bullets, but they will not deal as much damage. Range will be 4, shoot interval 0.03 seconds. It will shoot very fast. We have object pooling for the projectiles, so we can afford to do this without sacrificing performance. Projectile speed will be 8. Projectile duration 0.5 seconds, and damage 0.1. We can always come back and tweak these values later when we are balancing our game. I duplicate Burst Tower and rename the copy Strong Tower. Strong Tower will have a range of 3 units, shoot interval 1 second, projectile speed 4, it will spawn slow-moving projectiles. Projectile duration is 3 seconds, but these projectiles deal a lot of damage when they hit, maybe 10. Okay, so we have Burst Tower, Fast Tower, and Strong Tower. They will need their own prefabs. So far, we only have this prefab for Fast Tower. I create a duplicate and rename it to Strong Tower. I select it and lock the inspector. I go to Art, expand this sprite sheet, and drag this frame into its sprite field. I go to Scriptable Objects Tower folder, and I drag and drop Strong Tower into the data field on the tower script. Tower script remains the same for all towers. We will only change this data, which will completely redefine the tower's properties and behavior. I go back to prefabs and drag Strong Tower into the scene. If I play, this tower hits hard, but we can't really see that much difference yet. We will make each tower very distinct, but first let's duplicate the Strong Tower prefab and rename the duplicate to Burst Tower. My inspector is still locked, so I unlock it, make sure Burst Tower is selected, and I lock the inspector again. I drag this image into its sprite field. In the Scriptable Objects folder, I drag the Burst Tower data asset into its data field. Now I have a new Burst Tower prefab here, so I drag it into the scene. So we have a tower that shoots a lot of bullets. We have a slow, hard-hitting tower, and we have the base generic tower. We can now do so many different things with their data files to give them different behaviors or make them even more visually distinct. Let me show you an example of what exactly I mean. I open the tower data script and let's add something. How about projectile size? This will be a multiplier. Each tower will produce projectiles of different sizes. This will affect how it looks visually, but it will also have gameplay implications, because bigger projectiles have bigger colliders. My inspector is still locked, so I unlock it. Fast Tower will have projectile at its base size. Multiplier here will be 1. Strong Tower will have large, slow-moving projectiles. maybe double the base projectile size, or maybe 2.2 times larger. Burst Tower will shoot many small projectiles. Size multiplier here will be 0.4, 40% of the original size, less than half the base size. All of these three towers use the same projectile prefab. They all instantiate their own reusable pool of these projectiles, and they hold it nested under them in the hierarchy. So let's open the projectile script. I will create a start method, which will run once when the object is first created. Now we can access the scale values here and apply the multiplier from tower data to them. Projectile has access to tower data on line 5, and from there it can access the projectile size value we just added to the data for each tower type. Transform local scale is equal to the base size of the projectile, vector 3,1, which means 1, 1, 1. And we multiply the projectile's base value times data.projectile size. It's enough if we do it only once inside the start method here, because each tower holds its own projectiles. Once a tower creates its set of projectiles and sets the size here, we don't need to resize them again. Each tower will keep reusing its own set of projectiles. Save that. So strong tower, projectile size is 2.2 times the base size, fast tower keeps them at the base size, and burst tower shrinks them down to 40% of their original size. Just to keep it clean, I set the projectile prefab position to 0, 0. It doesn't really matter, since we move them around with code anyway. I will also set the position to 0, 0 on burst tower prefab, and on fast tower prefab as well. And actually also on strong tower prefab. And on waypoint. This will have no effect on anything, but I like to keep this clean. Enemy prefabs are all already on 0, 0 positions. To really see what we built, I need more enemies. Go to Scriptable Objects Wave folder. Wave 1 will spawn orc every 0.8 seconds, 15 of them in total. Wave 2, 20 dragons, once every 0.5 seconds. Wave 3 will spawn a kaiju every 1 second, 15 in total. I also go to the spawner script here and set time between waves to 1 second. Save that and play. Right, so now we can finally see a proper difference. We have 3 types of towers that all shoot the same projectile prefab, but they all do it in very different ways. We didn't change any code for separate tower types in the tower script or in the projectile script. Those scripts are identical for all types of towers. All we changed was the data we feed to those scripts, our scriptable objects. We can create more types of towers that shoot projectiles following this pattern we established, or we can keep this pattern even if we want to create different families of towers that don't produce this projectile prefab. Maybe they produce area of effect, like slow or fire, or another set of towers that produce bouncing energy beams, for example. The idea of how to do that would be to create code inside the tower script that is shared for all those different tower types. And the only difference would be in the data. For example, in the data, we specify what tower family this is. Is it a projectile tower, area of effect tower, or energy tower? And then in the tower script, we would create an if-else block that will only run certain parts of the code depending on the family this tower belongs to. That way, we keep this code base data-driven and we can have unlimited creative ideas when it comes to tower types. But this is going into a bit more advanced territory. Let's keep this beginner-friendly for now. I will align my towers a bit here by setting their positions manually. Strong tower, minus 5.60. Burst tower, minus 5.61. I select all my towers and I duplicate them. Use the move tool here, and I move the duplicate fast tower somewhere here. Strong tower here, and burst tower duplicate somewhere here. I will also round down their position values just to make this cleaner. It doesn't really matter. We will not be placing towers like this in the final game. I'm just creating an example game map. I do this because I want to trigger and show you 2 very common bugs that will happen in a game like this, and I will show you how to easily fix them. As I play, we have lots of enemies come in, multiple towers shooting projectiles all over the place, and lots of situations can happen now. For example, enemies might get hit by multiple projectiles from multiple towers at the same time. Enemies might get destroyed while they are in the range of 2 towers at the same time. Many different situations can happen now with so many towers and so many enemies on the screen. So some of these situations can create an issue. To debug our game, we have to understand what is happening and why. We programmed our game to wait until the previous wave of enemies reached the end of the path or was destroyed by towers before the next wave starts spawning. But here, we can see that we get the next wave spawning before the previous wave is done. Why would that be? I will go to the enemy script. We know our enemies invoke 2 events, on enemy reached end and on enemy destroyed. One is when the enemy reaches the last waypoint here, and the other is when the enemy's lives fall below 0. Inside Spawner, we are subscribed to these events, and in both cases, we increase enemies removed by 1. Only when we've spawned all the enemies in the wave and removed the same amount of enemies, we allow the next wave to come here. So why would the next wave come early? It's because this enemies removed count is wrong. 1 or more enemies got counted twice. Maybe the enemy reached the end and was destroyed in the same frame. Or the enemy got hit by multiple towers and invoked its event multiple times before it got deactivated. All these things can happen, potentially. All we have to do is prevent the same enemy from being counted twice towards enemies removed, and everything will be fixed. I will give enemies a private boolean I call has been counted. By default, I set it to false. This enemy hasn't been counted towards enemies removed yet. Down here, where the enemy reaches the last waypoint, we set has been counted to true, because this event will send a signal to Spawner and it will be counted there. Same thing here, when the enemy's lives drop below 0, that enemy has been counted as well. And when we initialize the enemy reusing it, I set has been counted back to false. If an enemy has been counted, it means it was either destroyed or it reached the last waypoint, so we don't need to run this update method for the next frame. If has been counted is true, we return early and don't run the rest of the code inside update. That will prevent this event from being accidentally invoked twice. Same in take damage. Once we enter this code block and has been counted is set to true, the event is invoked, which will cause the enemy to be counted towards enemies removed inside the spawner script. We make sure this code cannot run again. And down here, inside initialize, I have to make sure I reset has been counted to false when we reuse the enemy. And initially, it will also be set to false here. Okay, now it should work. We fixed a bug with the next wave coming too early. We have one more bug that can potentially happen. Look at this strong tower. It's shooting into empty space. Why is it shooting when there are no enemies in range? I pause the game while still in play mode. Let's select the problematic tower and enable debug mode to see its private enemies in range list. We are on the kaiju wave, but the tower is still holding a reference to a deactivated orc object. It sees it in its list and it's shooting at it, even though this orc is no longer in the scene and it was probably destroyed by another tower. There could be a scenario when an enemy is within a tower's range and gets destroyed. Our towers hold a list of enemies in range, and they add and remove enemies from it as enemies move in and out of range. But sometimes a specific set of circumstances can cause the tower to keep a reference to a deactivated enemy. I don't know what these specific circumstances are that make that happen occasionally, but I can still fix it easily. Our enemies are reusable pooled objects. We know that this orc it's holding in its list has been deactivated, probably because another tower destroyed it. So all we have to do to fix this is to make sure that towers keep active enemies in their lists and automatically remove enemies that were deactivated from their lists. I resume play mode and I go back to normal mode. When the orc wave comes again and that same orc game object is reused, the tower manages to clear it from its list, it seems. It's not shooting into empty space anymore, so it kind of fixed itself. But let's make sure this bug can never happen in our game. I open the tower script. This same script is shared for all our tower types. Every time, before the tower shoots, we will first check its enemies in range list, and we will filter out enemies that are null and enemies that are not active in hierarchy. Remove all method removes all elements that match a condition. I'm saying remove the enemy if the reference is missing, if the enemy has been destroyed, for example, and also if the enemy object has been deactivated in the scene, which is more likely here because we are reusing our enemies. Enemies are in object pools. That way, our towers will not shoot into empty space trying to target deactivated enemies. We have 3 projectile towers with different properties implemented in a data-driven way. We need a system that will allow the player to place these towers in the game world, if they have enough resources. To do that, we have to learn a few basic and useful UI techniques. Let me show you how to create a UI panel and how to create an in-game system that will allow us to show and hide it by clicking on game objects in the game world. We will use this panel to show the player a selection of towers whenever they want to place one. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I select all these towers and I disable them by unticking this checkbox, just to keep the scene a bit cleaner while we work on the UI. I will also disable the path, but I have to enable it before entering play mode. The way we wrote the code, the game will not play without a path. I right-click UI Canvas and go to UI Panel. Notice that its Rect Transform Components anchor preset is set to Stretch to fill the canvas. We can set its left, right, top and bottom offsets, and the size of the panel is calculated based on the distance between the anchors and the offset values we set here. I want to be able to set the width and height of the panel. To do that, I have to change the anchor presets from a layout with stretch anchors to a layout with fixed anchors. I hold down Shift and Alt, and I will go for this center middle preset. Now, these fields changed to X and Y position and width and height. I set the panel to 1400 by 800 pixels. We can also move it vertically up and down like this. It has a background image, and I can change its color here. I want to go for black, and this alpha slider all the way to 255 will make it non-transparent. We will use a panel like this for the pause screen and also for a menu to select which tower type to place in the world. I created this simple pixel UI image as a placeholder that will give us cards, buttons, and a cross for a closing button. You can download all resources in the description down below. Eventually, this will be replaced by a proper slick UI, but for now, this is fine. It's pixel art, and I want to keep it sharp, so I set filter mode to point no filter, and compression to none. I click apply. If I expand it, you can see Unity already sliced the individual elements automatically. I rename it to Tower Panel. I right-click the panel and select UI, Button, Text Mesh Pro. I will call it Close Button. Let's go to Assets Art, and I want this big X. With Close Button selected, I drag and drop it into the source image field. Right. I set its width and height to 170 pixels, anchor presets, and I go for top right while holding down Shift and Alt. I move it 50 pixels outside the panel like this. Okay, this will be our panel. It has a text element under it. I'll just delete it, no text needed here. I select Tower Panel and I uncheck this checkbox to disable it, and I check it to enable it. We want to be able to show and hide it like this, but with code. As usual, we'll handle it from inside the UI controller script. I need a reference to the entire game object. I'll call it Tower Panel. Save that. On UI controller, I see this new field for Tower Panel, so let's drag it in. I will create two methods. Private void show Tower Panel and hide Tower Panel. Here I say Tower Panel dot set active true, and here I set active to false to hide it. I will make this one public so we can call it from other scripts and from buttons in the Unity inspector. That way I can go here on the close button, I find its on-click block, and I click plus. I drag the UI canvas here, and here I select UI controller, hide Tower Panel. So when we click this close button, take UI controller and run its public hide Tower Panel method. Now if I play, I get an error. I exit play mode. This path game object has to be active, otherwise our game breaks. I might refactor that later, but for now it's not a problem. Path is active, UI canvas selected, and I play. Inside the game view, I can now click the close button and it will close the Tower Panel. Okay, great. We learned how to create a UI panel and how to create a button we can click to close it. I select the panel and it will be hidden by default, so I uncheck this. This panel will have cards that allow the player to choose which tower to place. So how do we open the panel? By clicking on a platform game object. Our game world will have platforms set all around the map that we can click, and we can choose which tower we want to place on them. Time to create the platform so that we can click it, and that click will open the tower panel. I go to my spreadsheet, and this small square will be the platform for now, placeholder art. I drag it into the scene and I rename it to platform. In the final game, this platform can look like anything we want. It can be almost invisible, blending in with the game world, if that's what we want. This is all just placeholder art. These platforms will be clickable, so they will need a collider to detect that click. I add component, box collider 2D. I could resize the collider, but I will actually leave it larger than the image, so that we can click somewhere around the platform and it will still trigger the click event. I go inside Scripts Tower and I create a new monobehavior script. I will call it Platform. Let's open it and I delete all the code inside. Platform game object selected, and I attach the platform script to it as a custom component. When we click this platform, I want to open the tower panel we made earlier. It will give us a choice of which tower we want to build on this platform. Detecting clicks on game objects in Unity can be a bit tricky if our scene has many towers with huge colliders around them and maybe other objects that also have colliders, because I want to only detect click on the game object that is this platform and its collider. So I want to detect a click, but I want to filter it. We will detect clicks on platform colliders only. I will use Unity's new input system, which comes pre-installed and enabled by default in Unity 6 and later. The new input system is notoriously quite complex compared to the old one, but it actually also has a simple syntax for quick actions. So let me show you how easy it can be. Basically here I just want to say if left mouse button was clicked using the new input system. The way to do it is to say mouse dot, and to be able to use it, we will need the Unity Engine input system namespace up here. Then we can say if mouse.current.left button was pressed this frame, Simple syntax using this new input system. Inside, we want to get the position in the game world where the mouse is currently pointing. Screen to world point takes the current mouse position in screen coordinates, pixels on the monitor, and converts that screen position to a world position, which is what Unity uses to place game objects in the scene. This line simply means detect where in the game world we clicked. I will now use raycast hit 2D to filter platform colliders to make sure our clicks don't get blocked by huge colliders when our game world is full of towers. This code is casting a 2D ray from the mouse position into the world to see if it hits something. Let's write this line of code and then explain it. World point is where the mouse click was detected. Vector 2, 0 is the direction of the ray. 0 means no direction. We want to detect something that's exactly under the point where the mouse was clicked. The next argument is the maximum distance the ray should check for collisions. Infinity means check as far as needed. And finally, layer mask is what the ray can hit. Here I'm saying only detect collisions with objects on the platform layer and ignore everything else. This is a pretty good way you can filter your clicks to only respond to collisions with specific objects in your game world. I just have to create this platform layer mask and associate platform game object with it. Let's create a private layer mask property. I will call it platform layer mask. Save that. Platform game object selected, and inside Unity Inspector, we have this layer dropdown. These layers can be used for a few things. In this case, we will use them for physics interactions to define which objects can collide or raycast with each other. We have some predefined layers here, but I want to add a custom layer. I will call it platform. Now I can select the platform game object and I associate it with my new platform layer. In the script, we have the platform layer mask field, and we set the layer mask to the platform layer, like this. Okay, so the platform is on the platform layer, and we are filtering this raycast hit 2D to interact only with objects on that layer. Platform game object has box collider 2D, so I say, if the raycast hits a collider, we know we clicked a platform because we are filtering all of the other ones out. And I save it in a temporary helper variable I call platform. It will be the game object that was hit, and on it I find the platform component. I know this seems like a lot of code to detect a simple click on a specific game object, but it's a quite robust and reliable way to do it, and I like to use it to make sure our game is not buggy. Debug log platform clicked, just to check if it works. Do you know another reliable way to use the new input system to detect clicks on game objects that are placed in the game world? Keep in mind, this is different than detecting clicks on UI, because for that we would use a completely different technique. Let's discuss that in the comments. I save my changes, and back in Unity I go to Assets Prefabs, and I drag the platform game object in here, turning it into a prefab. Let's drag out multiple platforms into the game world, maybe here. And let's put one up here and here, somewhere where the tower panel won't cover it when it's active. I enter play mode. I can click the platforms. And I'm getting the debug log. We are detecting platform clicks. Perfect. When we click a platform, I want to invoke an event that will carry with it a reference to the specific platform that was clicked. I will call it onPlatformClicked. I'm using action here, so we know we need the system namespace up top. When the platform collider is clicked, we invoked the onPlatformClicked event and we pass it the platform that was clicked. It's important we know which platform was clicked because later we will place a tower on that specific platform. UI controller has this function to show tower panel. I want it to run when a platform is clicked. I create a private method I call handlePlatformClicked. Inside, we will run show tower panel. Up here, we will subscribe to the platform on platform clicked, and as a reaction, we call handle platform clicked, which will open the tower panel. I'm getting an error because on platform clicked is carrying with it a reference to the platform. So I need to make sure it's expected as an argument here, like this. We will use it in a moment. First, let's try if everything works. As always, I should also unsubscribe inside the onDisable method. Okay, so we are filtering clicks here, and only if the raycast hits objects on the platform layer, it invokes the onPlatformClicked event. UI controller is subscribed to that event, and whenever it's invoked, it will run the handlePlatformClicked method that will open the tower panel. Save that, and let's see if it works. I play, I click any platform, and it will show the tower panel. I can close it by clicking the big white X, the close button. I click this one to open it, close button to close it. This is a very useful thing for your games. Clicking a game object in the game world to open a UI element, like this panel, useful in so many different scenarios. When the tower panel is open, I want to stop the game. I want the game to freeze so that the player can strategize and take time to think. Let's create a generic method to pause and unpause the game that we can call whenever we need it. I have a lot of freedom here in terms of where to place this functionality, but I think it makes sense to put it inside Game Manager. Down here, I create a public void setTimescale method. It will take a float parameter for scale. Inside, we set time.timescale to the scale value that was passed. The way time.timescale works, if it's 0, the game is frozen. If it's set to 1, the game runs at a regular speed. And for example, 2 means the game is running at double speed. And we will also do that later because this is a tower defense game and it needs buttons to speed it up and slow it down. But first, let's do this bit. I can follow the structure we used before, invoking events and reacting to them. But if we overuse this, it can result in a convoluted web of events and subscriptions. So in this case, just as my personal choice to keep this a bit simpler, I will implement a singleton pattern, which basically means make Game Manager available globally and call method on it from anywhere in our codebase. This line makes Game Manager instance globally accessible from any script. Get private set means other scripts can read it, but only this class can assign to it. Whenever we create a singleton, we have to do this bit in the awake method, and this bit of code is always the same. Inside the awake method, I say, if there already is an instance and it's not this one, destroy this duplicate. Otherwise, set this as the instance. This is a pretty standard thing to do. It prevents multiple instances, in this case multiple Game Manager objects, from coexisting to avoid bugs. So, I made Game Manager instance globally accessible so that I can call this public setTimescale method from other scripts. Let's do it. Inside UI controller, when we show tower panel, we pause the game. Game Manager instance setTimescale 0f. F stands for float. Inside hide tower panel, we set timescale back to 1f to make game time flow again. Save that and let's play. I click a platform. I close the panel. I click a platform. Tower panel shows. Game is paused. I close the panel and we play again. I open tower panel to pause the game. Close it to play again. I hope you learned something new in this lesson. In the next part, we will add some cards representing our 3 tower types, and we will be able to choose which tower we want to place on the platform we selected. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I start by selecting all these deactivated towers and deleting them. We will place towers on the platforms from now on. I want to create a set of cards, one for each tower type. When we click a platform, we open a panel with a selection of cards to let the player choose which one to place. I open the tower data scriptable object and I will define a few more properties. We will need an integer for cost, how many resources it costs to place this tower type. And we will need a sprite, an image that will represent the tower on the card. Save that. Inside Scriptable Objects Tower folder, Fast Tower Data Asset, I set the cost to 50 resources. If you want, you can lock the inspector here. I will do it without locking it by clicking the Art folder, expanding this sprite sheet, and dragging the Fast Tower image into this field. I want this image to represent the Fast Tower on the selection cards. You can choose a different image if you want. It doesn't have to be the same image we use for the actual tower game object. I'm just using the same ones for simplicity. Back to the tower folder, Burst Tower Data Asset will cost 75 resources. In the Art folder, I drag and drop this image into the sprite field. Finally, Strong Tower. Cost will be 100 resources. And sprite will be this one, so I drag it in. So all three data assets have a cost value and a sprite image. On UI canvas, I select Tower panel and activate it here. Let's deactivate the path for a moment, just so I have a cleaner workspace. I right-click Tower panel and I create an empty game object nested under Tower panel. I will call it Tower Card. I go to Art and I find my Pixel UI art asset. On Tower Card game object, I add component, image. I drag and drop this card frame image into the source image field. Card width will be 300 and height 450. I right-click Tower Card and I go to UI Image, making sure it's nested inside the card. The image will be 200 × 200 pixels. For anchor presets, I hold down Shift and Alt and choose Top Center. Move the image 75 pixels down here. I right-click the Tower Card game object again and select UI Text, Text Mesh Pro. For anchor presets, Shift and Alt, and I select Bottom Center. It will be 300 × 100. Alignment center middle. Font size 50. I move it vertically and adjust the height. Maybe this looks fine. So this will be a tower card. What it displays, which image and which text will depend on the data asset we connect to it. I rename this to tower image and I rename this to cost text. Default text will say something like cost. I go to Scripts Tower folder and I create a new monobehavior script. I call it Tower Card. I attach the Tower Card script to the Tower Card game object as a component and I open it. Inside, we will need a field for image. I call it, for example, Tower Image. To be able to use this, I need the Unity Engine UI namespace up here. We will need another field. Type is TMP text, so the TM Pro namespace here, and I call it cost text. I need a method that will check data and associate this card with the image and cost of that particular tower type. It will be public because I want to be able to call it from outside this script file, and I will call it, for example, initialize. I will take the tower data as a parameter, and I call it, for example, data. Inside, I set towerimage.sprite to the sprite we put into the tower data, and costText.text will display the cost of the tower coming from the data. Cost is a number, and we want to display it as text, so I convert it to a text string using the built-in toString method. So we have a tower card. When we call initialize from somewhere in our code base, it will take tower data as an argument and it will set the image and cost text on that card based on the data we pass to it. Save that. On the tower card game object, I see two new fields. I drag its tower image here and cost text here. Inside Assets Prefabs, I drag tower card in, turning it into a reusable prefab. We will need it because we want to create multiple cards. It turns blue here, telling us it's a prefab now, so I can delete it from the scene. I have the card inside my prefabs folder saved for later. I want to create, let's say, 3 of these cards dynamically with code and align them in some sort of a grid under the tower panel. In Unity, we can organize UI elements in a grid very easily. I right-click Tower Panel and I create an empty game object. I will call it Cards Container. Anchor is center middle here, so I can set its width and height. I will go for 1300 times 500 pixels. I don't know if my game will display 1, 2 or 3 cards. It will depend on how many cards I have unlocked. So I will give Cards Container a component called Horizontal Layout Group. It automatically arranges the child UI elements of Cards Container in a horizontal line. That way, we don't have to manually position each card, and we make sure they align based on how many of them we display. I will show you. Horizontal Layout Group is great if you want automatic horizontal arrangement, consistent spacing and alignment, and dynamic resizing support. It does all of that automatically. We just need to set it up. With Cards Container selected, I drag and drop Tower Card Prefab under it to create 3 copies, like this, just so we can see how the alignment works. Cards Container selected, and I set Child Alignment to Middle Center. Perfect. If I delete one of the cards, you can see the 2 remaining ones reposition, like this, still evenly spaced out. And if we have only 1 card, it will be centered, like this. This is exactly what we need. Let's delete this card. I have Cards Container with a horizontal layout group, and we know we can dynamically add up to 3 cards under it, and they will be perfectly aligned. I right-click Tower Panel, and I select UI Text. I will call it Title. The text will say Choose a Tower. Anchor preset, I hold Shift and Alt, and select Bottom Center. Width 1200, height 100. Text alignment center middle. Font size 50. I move it up vertically a little bit. Cards Container selected, and I move it vertically up as well. Tower Panel selected, and I disable it. I play. I forgot to enable path again. I exit play mode, enable path 1 game object, and enter play mode again. When I click any of the platforms, we get Tower Panel. I want to dynamically generate 1 card per each tower type to give the player a choice. Which tower do you want to place on this platform? Where will I handle that logic? For a bigger game, I would create a separate Tower Manager script, but for our small game here, I can handle that inside UI Controller, since that's where we handle all other UI elements as well. I will need a field for the Tower Card Prefab. It is a game object. And I need a transform for Cards Container. Save that. On UI Canvas, I see the new fields, so I drag Cards Container in here. And from Prefabs, I drag Tower Card Prefab in. I will keep an array that holds tower data. I will call it Towers. We will have a list of game objects. I call it Active Cards, and initially I set it to a new empty list. To be able to use list, I need System Collections generic namespace up here. Down here, I create a private void method called Populate Tower Cards. Whenever we call it, first I want to make sure we delete the old cards if there are any. So for each card in Active Cards, destroy that Tower Card Prefab instance. And then clear the list to make sure it's empty. After that, I will cycle over the towers array that holds data asset files for each tower type. We defined it up here on line 15. Let's actually save this, and on UI Canvas, I see the towers list here. I go to Scriptable Objects Tower folder, and I drag Fast Tower in. Let's leave it like this. And back in the script, for each data asset inside this towers array, I create an instance of tower card prefab. Temporary helper variable, game object type, I call it card game object. We know that instantiate method creates an instance of a prefab, a copy of a prefab. That prefab is tower card prefab from here. And as its parent element, I set this cards container like this. I need its tower card component, so one more helper variable of tower card type. I call it, for example, card. It will be the card game object we just instantiated, dot get component tower card, like this. Why do we need this component? Let me show you. Save that. Prefabs, tower card prefab here. I open tower card script that we just accessed from inside UI controller, and we need it because we want to call this public initialize method, which will fill the card with relevant image and cost text based on the tower data we pass to it. So I call it using this card reference .initialize, and I pass it data. As we cycle over towers array, data will represent all tower types one by one, filling them with relevant data. And as we do that, still inside the for each loop, we add that card we just created and filled with data to active cards list. Okay, so we destroy the old prefabs, we clear active cards list from old data, and for each data asset inside towers list, we instantiate a copy of tower card prefab. We fill it with data for that particular tower type, and we add it to active cards list. Now I just have to call this every time I show tower panel, which we know runs every time we click any platform in the game world. I save that, UI Canvas selected, and the towers list has only the fast tower in it at this point. I play, I click a platform, and we get a card with the image and cost for the fast tower. Let's say that this is how the game starts. We've unlocked only one basic tower type. But as we play, we unlock more types of towers. I exit play mode, I go to Scriptable Objects Tower, UI Canvas selected, and I drag the burst tower into the towers list. So now I have two. If I play and I click a platform, this is what it looks like when we unlock two tower types. They align horizontally. I exit play mode, I add the strong tower to the list, and when I play, when I click a platform, we have all three towers displaying their sprites and their cost to the player. If you have more tower types in your game, you can always make the cards smaller to fit more of them here. I will keep it simple for now. Now the fun part. Let's write some code that will let the player click one of these cards, and the tower they select will be placed on the platform. On the tower card script, I define a private variable. The type is tower data, and I call it tower data like this. When we initialize a tower card to fill it with values for the image and text, we also take the incoming data and save it as tower data here to make sure this tower card knows which tower data type it is associated with. Then I will make tower card broadcast an event, public static event using the action keyword, and it will carry with it the tower data of the selected tower type. I will call the event, for example, on tower selected. To be able to use action, I need the system namespace up here. I will have a public place tower method here. When called, we will invoke the on tower selected event, and we pass it tower data. So whichever script subscribes to it will know which type of tower was placed. This method is public because I want to call it from a button click. Save that, prefabs folder, and tower card prefab here. I add a component to it, and it will be a button. It has an on-click block here. I click plus, and I drag in tower card itself. And here we will run tower card place tower. So when the tower card is clicked, it will call the place tower method, which invokes an event broadcasting to other scripts which tower was just placed. I go back to tower data and I add one more field of game object type. I call it prefab. We need to know which prefab is associated with which tower type. Save that. Burst tower data asset selected, and we can see the new prefab field here. If it helps you, you can always lock the inspector here. I don't need to do that. I just go to the prefabs folder, and with the burst tower data asset still selected here in the inspector, I drag and drop the burst tower prefab into this field. Back to Scriptable Objects tower folder, fast tower data asset selected, and I make sure I see it in the inspector here. Prefabs folder, and I drag the fast tower prefab into the empty prefab field. And one more time, this time for the strong tower, prefabs folder, and I drag the prefab into the prefab field. Okay, so we added this line to the script, and we made sure all tower data assets have a value in this field. Whenever we click a tower card, this place tower event will run, which invokes a function that carries with it tower data, which contains the specific prefab we want to place. Save that, and inside the prefabs folder, platform prefab, I set its position to 0, 0, just to keep this nice. Let's open the platform script. I could have a separate tower manager script to do that there, but for our small game, I will handle placing towers here. I create a public place tower method, which will take tower data as an argument, and I will call it, for example, data. Inside, we will instantiate the prefab from that incoming data. Where do we want it? At the position of this platform. Rotation will be the same as the platform, so no rotation. Quaternion identity means no rotation. And I want the tower nested under the platform in the hierarchy, just to keep it clean. So as the parent, I set transform, which means set this platform as the parent of the tower we are about to place. So now, let's open the UI controller script. We have the tower card script. When a tower card is clicked, it will run the place tower method that will invoke this event, carrying with it the data of the tower that is associated with the card that was clicked, so we know which tower the player wants. UI controller will subscribe to that event, towercard.onTowerSelected plus equals handle tower selected. And as always, we also unsubscribe here. This method doesn't exist yet, so let's write it. Down here, private void handle tower selected. We know that the event is carrying tower data with it, so we make sure it's expected here. Like this. So now, UI controller knows which tower was selected, and I will need to know which platform we want to place that selected tower on. So up here, I define a private property. Type is platform, and I call it current platform. The platform that was clicked, and we are about to place a tower on it. The platform class has this public method that will set the platform itself as the parent of the tower. So how do we keep track of what is the currently selected platform the player wants to place a tower on? We can do it in here because we are already subscribed to handle platform clicked, and we already made sure that this event is carrying with it platform that was clicked. So convenient, almost as if we planned this. So whenever any platform is clicked, we will always set it to current platform here. And when a tower card is clicked, handle tower selected will run. We know what the current platform is, so we take it, and we will call its public place tower method, passing it the tower data of the selected tower the player clicked when choosing from the 3 tower cards. And here, the instantiate method will run, creating an instance of the prefab from tower data, placing it at the position of this selected platform, and setting the selected platform as the parent in the Unity hierarchy. Once we select a tower, we can hide the tower panel, which will also unpause the game and resume gameplay. I save that and I play. This is probably the most complicated thing we did so far in this class. From my experience as a beginner, the biggest struggle always was keeping track of the logic between script files, how the methods talk to each other, and how the data is passed around. This was quite advanced because so many things happen between files, but you made it. We are here, and we can click any platform, we get a pop-up, and we can choose which tower to place. When we choose it, the game will place the tower we selected on that platform. Finally, we have something closer to a playable game. After this, the rest of the class will seem so easy for you. What's next? Right now, we can place unlimited towers because they are free. Let me show you how to clean this up to prevent bugs, and then we will implement a simple mechanic that spends resources when we are placing towers. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. So here is a bug and how to easily fix it. I play my game and notice I'm clicking on this platform. I want to place a tower here. I get a tower panel pop-up, but before I choose a tower, I click on a different platform, let's say by accident, for example on this one. And when I choose a tower, it isn't placed at the platform I selected originally, it's placed on the last platform I clicked accidentally. Let's try one more time. I click this platform, I want to place a tower here, but while the panel is open, I click this other platform, and only then I choose a tower. The tower is placed on the last platform that was clicked. I want the tower to always be placed on the platform that initiated the opening of the tower panel. Once the tower panel is open, we should not be able to switch platforms again until we close the panel first. This is a very easy fix. I exit play mode and I open the platform script. Let's do a public static auto-implemented property. The type is Boolean, and I initially set it to false. Public means it can be accessed from anywhere, and static means it belongs to the platform class itself, not to any instance of the class. This getSet allows us to read and write this property. I want to have this global flag that can be checked and unchecked to track whether the tower panel is open or closed. If the tower panel is open, we return, preventing the rest of this code from running. So if the tower panel is open, we are no longer detecting clicks on platforms. This means that after we open the tower panel, it's impossible to accidentally select a tower platform and place the tower in the wrong place. Now I just have to make sure this global flag is being set to true and false appropriately. It's public, so I can access it from other scripts. Save that, and I open UI controller. Inside Show Tower Panel, I access the platform class and that static property we just defined called Tower Panel Open, and I set it to true. As we said before, the static property belongs to the platform class itself, not to any instance of the class. When we open the tower panel and set it to true, we are no longer detecting clicks on other platforms here. And when we hide the tower panel, we set tower panel open to false, allowing clicks on platforms again. Save that and play. I click this platform to open the tower panel. While the panel is open, I click this other platform. Then I place a tower, and the tower was correctly placed on the original platform that initiated the opening of the tower panel. Perfect. We fixed it, and we learned a use case for public static properties. I exit play mode. I move Game Manager up here just to stay organized, and I open Game Manager script. I set the initial resources to 175, so we have enough to get a few starter towers. Down here, I create a public method called spend resources. It will take one parameter, an integer for the amount. If our current resources are greater than or equal to the amount we are trying to spend, initially we start with 175. we take the current resources and reduce them by the amount. And whenever resources change, we want to invoke onResourcesChanged event and pass it the updated resources value, which will make UI controller update the resources display text. Inside UI controller, whenever we select a tower we want to place, we will call this new public spend resources method that is sitting on Game Manager instance. And the amount we want to spend depends on which tower was selected. So we take it from towerdata.cost, like this. Save that and play. I click a platform, and depending on which tower I choose, that amount of resources will be deducted from my total resources. Let's say I select the strong tower, which costs 100 resources. The tower is placed, and I only have 75 resources now. But if I choose another tower that costs 100, we can place it, but that amount was more than what we have, so the resources were not deducted. If I choose a tower I can afford, like this one, that costs 75, it will deduct the resources correctly. I can keep placing towers even if I have no resources to afford them. So let's adjust the code a little bit. Every time I want to place a tower, I need to check how many resources we currently have. This is a private property I can't access from other scripts, so let's create a getter, a way to read the current resources amount from anywhere in our codebase. This is a shorthand syntax that creates a public read-only property I call resources. When I use it, it returns the value of this private variable. Since there is no setter, we cannot assign a value directly from outside the class. We can only read this current value. In short, this line exposes the private resources variable publicly as a read-only property. A simple getter returning the private field's value securely. So here in UI controller, when the user selects a tower by clicking one of the cards, we first check if the resources we currently have are greater than or equal to the cost of the tower we are trying to place. Only if we can afford it, we spend resources and place the tower. I put this hide tower panel outside the block because even if we can't afford the tower, we will close the tower panel and resume the game. Okay, let's playtest again as we go just to make sure everything is working so far. I place the strong tower for 100 resources. I place the burst tower for 75 resources, and now I have 0. So if I try to place another tower now, the panel will close, but there is no tower placed on the platform. Perfect. I want to display a message that will tell the player that they can't afford to place the tower. I make sure I'm not in play mode, and I right-click Resources Text. I go to UI Text Mesh Pro. I will call it No Resources Text. I make sure it's nested under Resources Text, because this error message will relate to that field. With No Resources Text selected, I go to Anchor Presets. While holding Shift and Alt, I go for top center here. Width will be 600 and height is 50. I want to move it down, maybe minus 75. The text will say not enough resources. Alignment center middle here. And text color will be red. Okay, I move it up, minus 50 here. That's better. And I make sure I spell resources right. By default, it will be disabled. This text will only appear when the player tries to place a tower they can't afford. This message will appear for a few seconds, and it will automatically disappear again. To do that, I need a reference to the entire game object up here in UI controller script. I will call it No Resources Text. Save that. On UI Canvas, I find the field here, and I drag No Resources Text inside. Notice this is text, same as these, but the type here is game object, not TMP text. We do this because we want to show and hide the entire game object dynamically. We don't want to modify the text it contains, so that's why the different type here. Down here, inside the handle tower selected, I create an else block. And inside, I want to start a countdown to show and automatically hide that error message. So start coroutine, and I pass it show no resources message like this. This function doesn't exist yet, so I define it down here. private IEnumerator. And to be able to use this, we need System Collections namespace. My compiler is also accepting it from System Collections generic namespace up here, so let's see if it works. Down here, I will call it Show No Resources message. And inside, I will first immediately make the No Resources text visible. Then I will do a countdown of 3 seconds using yield return new wait for seconds 3f. And after 3 seconds, we deactivate No Resources text again. And now I can see I can't actually use IEnumerator from this namespace. I need to go up and use System Collections for the non-generic IEnumerator, because that one is what Unity's coroutine system uses internally. Okay, now we got this right. When we select one of the towers on the cards, if we have enough resources, we place the tower. Else, meaning we can't afford it, we start the coroutine. This countdown that will do things with a delay. In this case, it will show the error message, wait 3 seconds, and hide the message again. We will also immediately hide the tower panel. Coroutines in Unity are methods that can pause execution and continue later. They can run alongside the rest of our game logic without blocking it. The most common use case is this, where we want to create a delay between events, when we want to wait a little bit and run some code with a delay. Let's save that and play to see if it works. I will place some towers to spend my resources. Now I have only 26 resources, which means I can't afford any of these towers. If I click one of them, the panel closes and I get the not enough resources message that will show for 3 seconds and then disappears again. I try again. Let's try to place a tower we can't afford. And again, I get the warning message that I don't have enough resources. Awesome. Also notice that towers we place are nested under their associated platforms in the hierarchy. This is good to keep this area organized. We learned how to show and hide messages to give player feedback, a useful skill in game development. We are also no longer able to place towers if we can't afford them, so we cleaned tower placement up. We have a pretty solid system here, nice work. I exit play mode and I create an empty game object. I call it platforms. I will put all platforms inside, just to keep this tidy. If I want these platforms to be aligned perfectly, I can adjust their x and y coordinates manually here. It's not necessary, but it will look better. You might have a different map and different platform placement, so don't worry about this. I will just clean up my platforms. I will actually delete all of them and leave only this one at position -5 plus 4. Let's start from up top here. I copy and paste it 5 times. Notice my parent platform's game object is not exactly at position 00, which might help with alignment. I can move all the platforms by moving just the parent. This helps me to be able to use whole numbers for the platform positions to make this part easier. If I can't place the platforms by using whole numbers, whole units, on the platforms themselves, I can move the parent's platforms object to some position with decimal points, just so I can use simple coordinate systems for the platforms. Positions like -5 plus 3 for this one. And all of them are horizontally at -5, and this one is vertically at 2 units. This one is under it, so +1 vertical position. This one is at position 0, and this one is -1. I copy this one and let's place it at -2. So we have a nice line of platforms perfectly aligned. It's not that necessary, we will move them later depending on world map art, but I like to have clean lines. You don't have to align them like this, it's just for me. I duplicate platform 6 and I set platform 7, the duplicate to -5, -4 down here. Another duplicate to -6, -4, and another one at -4, -4. Next one will be at position around here, so I move it. So that will be -2 plus 2. Duplicate it, and this one is at position -1 plus 2. And one more at position 0 plus 2. Yes, I like how they are aligned in neat lines. As I said, you don't have to position them in the same way. Put your platforms wherever you want them. Design your own map if you want. There is always source code you can download with my Unity project that will have the platform placements exactly as you see here. The next platform will be at 0, -1. I will speed this up a bit. 0, -2, +1, -2. I duplicate it 7 more times. This one will be at +1, -1, +2, -1, +2, -2, 3, -2, 4, -2, 5, -2, 6, -2, and a few more up here around this area, I guess. So 5, 1, duplicate it, do 6, 1, and one more at 7, 1. Okay, we have a nice organized map layout with plenty of platforms. Players can strategize and choose where to place their towers. If I select the parent platforms object that contains all the platforms, and if I place it at 0, 0, it will be too far to the right side. I can just use the move tool and position my platforms exactly where I want them, all of them at the same time, like this. This looks good. I can collapse this to hide them. I might move them around a bit later as well. For now, this is good. Let's play. I have all these places now where I can place my towers. The projectiles are not that fast, so the platforms we choose can affect if the tower hits or misses the enemy because of the angles where the enemy is coming from towards the tower. We have so many features already, but I can just keep going. What should we implement next? How about 3 buttons that will make the game run at different speeds to allow players to fast forward through the easier waves and slow down during the more intense moments. It will also let the players match the game to their personal pacing. Some like to play with slow, careful planning, others prefer quick action. Our game can work with all of these kinds of players. Let me show you how. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I need a little bit of space in one of the corners for 3 UI buttons, so I will move these 2 platforms. Move this one to -3, -4, and this one, let's put it here at -2, -1. I want this corner empty for some more UI. I right-click UI Canvas and I create an empty game object. I will call it Speed Buttons. I make sure Speed Buttons is nested under UI Canvas. I right-click Speed Buttons and I go for UI Button Text Mesh Pro. I will call it Speed 1 Button. It will be 100 pixels wide and 100 pixels tall. I select this Speed Buttons container object, anchor presets, with Shift and Alt keys pressed. I select bottom left, that will move it down here. Button selected, it has a text element inside. I set it to a greater than sign for now. Text color will be black. Font size 50. I make sure the alignment is middle center here. I select this Speed Buttons container object. It's set to bottom left, but I set this to 0. Okay, let's do 50-50. Button selected. I copy and paste it 2 times. I make sure all 3 speed buttons are direct children of the Speed Buttons container. I rename this to Speed 2 button. Its text will use 2 greater than symbols. And this one will be called Speed 3 button. And the inner text will show 3 greater than signs. Right now, all 3 of these buttons are stacked on top of each other, so let's select the parent, Speed Buttons game object, and I add a component called Horizontal Layout Group. Child alignment middle center, and spacing maybe 5 or 15. We will add functionality to them inside the UI controller script, where we handle most buttons and UI elements. We will need fields for the 3 buttons we just created. Type is button, and I call it speed1 button. To be able to use button here, we need the Unity UI namespace. I duplicate it 2 more times, and this will be speed2 button, and speed3 button here. Down here, I create a method that will set game speed. It will take a float value for timescale as a parameter. We have this set timescale method that we are using to pause and unpause the game when the tower panel appears. So for now, this will be used for that, when the game needs to be paused because the UI needs it. For game speed buttons, I have to do it separately here. I can't set timescale directly from the speed buttons. I will show you why in a moment. So public void set game speed. It takes a parameter of float type I call new speed. Game manager will keep a private float value for game speed. By default, it will be 1, the normal speed. We also need to be able to access this game speed from other scripts as a read-only property, just to check what was the last game speed set up by one of the 3 speed buttons. Inside set game speed, after we press one of the 3 speed buttons, we will set that private variable that keeps track of the current game speed to the new speed coming from the button. And then we will call set timescale, which will actually make the game run at that speed. Now to call this function back in UI controller, when we click one of the speed buttons, we call GameManager.instance.setGameSpeed, and we pass the timescale along. Up here, I create a start method. It runs only once in the beginning. I give the speed buttons an onClick event. This is a Unity event that triggers whenever the button is clicked. The addListener method registers a callback. This is a lambda expression, an anonymous function. This syntax means, when called, do what's inside the brackets. So this code says, when speed1 button is clicked, call the setGameSpeed method with an argument of 0.2f. You might notice that usually I would just find the button inside Unity. I would find its onClick block there, and I would trigger setGameSpeed that way. We did it that way a few times in this course, but I want to pass setGameSpeed this argument of 0.2, defining how fast the game should run. That's why I'm doing it in code instead of inside the Unity inspector. In the inspector's onClick event, you can only assign functions with no parameters, or functions taking a single parameter of a type Unity can serialize, like a game object or a string, but you can't specify arbitrary numeric arguments like 0.2f directly in the inspector. Using code with a lambda like this lets us assign any arguments we like. So now that we understand what this line does and why we decided to do it this way, let's do the same thing for speed2 button, which will set game speed to 1, the normal speed, and speed3 button, which will set game speed to 2, double the normal speed. The first button with 0.2 will make the game run very slow, 1/5 of the normal speed. We can change these values later, however we want. Maybe you want a button to make the game 4 times faster. You can just put 4 here as an argument and it's done. Let's make sure we assign speed buttons to these fields. Save that, and with UI canvas selected, I will see them here. So I drag speed1 button to its field here, speed2 button here, and speed3 button here. If I play, the buttons already work. This one will make the game run at 1/5 of its normal speed, very slowly. This button is double the normal speed. Notice this behavior. I click the platform that showed the tower panel. Our game is paused, as expected. It was running at double speed, but when I select the tower, the game runs at normal speed. So our speed buttons work, but we know we have a small issue where selecting a tower sets the game speed back to normal. I want the game to remember what was the last speed selected by one of the 3 speed buttons, and when a tower is selected and the game unpauses, it returns to that speed. The issue is here, inside the hide tower panel method. When we close the panel, we set timescale to 1. That's why earlier we created this separate method called setGameSpeed. That first saves the preferred speed coming from one of the 3 buttons in a variable, and then it calls setTimescale, which will actually make the game run at that speed. We are storing the game speed that the player wants based on their choice between the 3 speed buttons here on line 15, and we are exposing it as a public read-only property here on line 16. So here, when we hide the tower panel, instead of going back to speed 1, we will go to whatever is the last stored player-preferred speed, which we are exposing as a public read-only property under Game Manager instance game speed. I hope this makes sense. Let me know in the comments if you have any questions. I play to test this. Let's try the slowest game speed. And I open the tower panel, which will pause the game. When I select the tower and the game unpauses, we are still at the slow 0.2 speed. Perfect. As I said before, I assigned 0.2, 1 and 2 modifiers to these buttons, but you can go into the code and give them different modifiers. Maybe you want 1, 2 and 4 times the game speed. I'll leave it up to you. I'm just giving you this template and showing you how things work. How you actually design your game is up to you. I think some of you would also want to have the active speed button highlighted in a specific color as a confirmation, so we can see which speed the game is currently running at. Let's do it in a bit more robust way, where we define global button colors here, so that if we add other buttons later that need to be highlighted, we can reuse these colors there. I want to be able to see and modify these in the inspector for now, so serialize field, private color, normal button color is equal to color.white, which is not exactly what it seems. In Unity's UI system, the color property acts as a multiplicative tint, applied on top of the sprite's original pixels. For example, if you have a blue button and you set its color to color.white, Unity multiplies each pixel's RGB by 1, which leaves the sprite's original colors unchanged, so the button stays blue. This can be confusing at first. The important thing to remember is that setting a button's color to color white removes any tint, displaying the sprite's original appearance. To clarify, I'm not saying the normal button color is literally white. Rather, the normal state is untinted, showing the sprite exactly as it was created in its original colors. We will also define selected button color, maybe color blue, for example. Let's also recolor the text on the buttons. Normal text color is black. Any color multiplied by black will result in black. Selected text color will be color white again, so not white in the sense of plain white, but whatever color it was originally. I hope this makes sense. Let's create a private method I call, for example, update button visual. It will take 2 parameters, the button we want to style, and a boolean I call is selected, which can be true or false. Let's write this line of code and then we explain it. Button image color is equal to is selected, question mark, selected button color, colon, normal button color. Here I'm saying access the color of the button's image. If is selected is true, set it to selected button color. Else, set it to normal button color. This syntax is called the ternary conditional operator. In this case, it's just a way to write an if-else statement on a single line. Expanded version would look like this, and it would work exactly the same. So ternary operator, because it has 3 operands, the condition to evaluate, if true, question mark, do this, else, colon, do this. At the same time, I also want to recolor the text of the button, which we know is a game object nested under the parent button. Let's access it directly here to make this easier. Type is tmp text, and I will call it text. It's the button we are updating. And I want to find that child text game object and its tmp text component. So text is equal to button.getComponent in children and type is TMP text. If there is an element we can find there, if it's not null, we take it and set its text color, again depending on if the button is selected or not. If it's selected, we use selected text color. If it's not selected, we use normal text color. So this helper method is setting the button and text color between selected and normal. Every time we select any of the 3 speed buttons, we have to run this method for all 3 of them, setting one of them to selected colors and the other 2 to normal colors. We will handle that logic here inside a method I call highlight selected speed button. It will take a float parameter for selected speed. Let's write this line and then I'll explain it. So I call update button visual. As the first parameter, we pass the button, speed1 button, and as is selected true or false, we do an expression to evaluate if selected speed is equal to 0.2f. This might be a bit strange, so let's do it for all 3 buttons and then I'll explain how it works. Right, so every time we call highlight selected speed button, we will always call update button visual for all 3 buttons we have. We pass each button as the first parameter, speed1 button, speed2 button, speed3 button. And as the boolean is selected, we check if the speed that was selected matches the speed associated with this button. Only one of them will match and be selected. For example, let's say we selected a speed of 0.2. Then selected speed equal to 0.2 will be true, which means speed1 button will be colored in selected button color and selected text color. And the other 2 will be false, because the selected speed won't match those values. So the remaining 2 will be colored in normal button color and normal text color. I like this shorthand syntax, I think it's pretty clean. The only thing to keep in mind is I'm hard-coding 0.2, 1 and 2 here. So if I ever decide to change the speeds associated with my buttons, I have to change these values here and the values up above so they match. Otherwise, none of the buttons will get highlighted because none of them will match. Does it make sense? Let's talk about it in the comments if you want. Okay, yes, so finally, every time we click one of the speed buttons, we need to run this highlight selected speed button method to color our buttons. Notice it takes selected speed as a parameter, so here, when I call it, I pass it along time scale, which will be either 0.2, 1 or 2. It will all work nicely together. Maybe we could put these 3 values into variables later. For now, let's see if it works. Keep in mind that clicking these buttons will call setGameSpeed and it will carry with it this value. That timescale value will then be passed along as an argument to highlight selected speed button, and if that value matches one of these 3 buttons, that button will be highlighted and the other buttons will be set to their normal colors. That was pretty intense. Let's see if it works. I play. And let's go to the fastest. Slow it down, speed it up, and normal speed. Yes, buttons and text inside change colors exactly as we need. What if I want one of the buttons to be automatically selected even as the game first starts? I can just go here inside start method. I call highlight selected speed button and I pass it the current game speed from the read-only property we defined on Game Manager instance. Like this. Now if I save and play, the normal speed button is immediately highlighted when we start the game. We're doing some cool stuff with UI, and this is only placeholder assets. It will look even better when we use a proper asset pack. Maybe I should resize the tower panel now that we added these new buttons. I make sure I'm not in the play mode and I set tower panel to active here. I reduce height to 700 pixels. Cards container selected, and I set the vertical position to 0. Title text selected, anchor presets, I hold down Shift and Alt, and I set it to top center. Vertical position maybe 50. I set font size to 75. Vertical position 30. I'm not sure about this yet. Tower panel can now go a little bit up so it doesn't overlap with speed buttons. 0 here. What does this look like? Close button selected, and I do 75, 75, like this. Let's put the title text inside, -20 maybe. And I move cards container a bit down as well, -20 or -50. Yes, this looks better. I hide tower panel again and I play. When I open tower panel, we can see the new layout and the panel is a bit smaller, so there is some space between it and the speed buttons. This looks pretty good. I can now play my game at double speed, which might be useful at some point. Awesome. Let's also add a pause panel, and on it we give the player some options to restart or quit the game. This will be much easier than what we just did. Unity handles most of this automatically or with just one line of code. I right-click UI Canvas and I go for UI Panel. And I call it Pause Panel. I make sure Pause Panel is nested under UI Canvas. Anchor presets with Shift and Alt. I select Center Middle. I think I want the Pause Panel to look the same as the Tower Panel, so width is 1400 pixels and height is 700. Color will be black and alpha set to 250, so a little bit transparent. Sorry, I think you can't see this panel fully. I right-click Pause Panel and I select UI Text Mesh Pro. I call it Title. The text will say Paused. Font size 100. Anchor top center. Width 600. Height 100, alignment center middle, and -20 vertical position here. On the deactivated tower panel, I select Close button, I copy it, I select Pause Panel, and I paste it to create a duplicate. I make sure it's nested under Pause Panel, like this. Okay, so we have a pause panel that looks the same as the tower panel. Close button selected, on-click block down here. For now, I will set no function. We will get back to this. Now I want to have a way to show and hide the pause panel, to pause and unpause the game. I right-click UI Canvas and I select UI Button Text Mesh Pro. I will call it Pause Button. It will be 100 × 100 pixels. Anchor presets, Shift Alt, bottom right corner, and position will be -50, 50. The text inside selected, and text input for now just 2 vertical bars, which roughly looks like the standard pause symbol. Just a placeholder. Color will be black, font size 50, alignment center middle here, and maybe let's make it bold. Okay, so when we click this button, Pause Panel will show. I expand Path 1 and this waypoint object. I will move it slightly to the left, not too far, maybe 7 horizontally here, and the waypoint below also 7. This is just to make sure enemies don't walk under the new pause button. Okay, this looks good. As always, we start by creating a new field inside UI Controller. Type will be Game Object, and I call it Pause Panel. Game Object type because I want to show and hide the whole thing. And another field, type is Button, and I call it Pause Button. Save that. On UI Canvas, I see the new fields here. I drag Pause Panel here, and Pause Button into this field. Actually, I would need a reference to the pause button if I was planning to assign on-click event to it in code. I can do it in the same way we did it for the speed buttons here, but actually I will delete this. We will assign it inside the Unity inspector, it's easier. Okay, so I have a field only for pause panel here. I will create a custom method I call toggle pause. It will need a helper flag, private bool I call isGamePaused. Initially, I set it to false. When we call toggle pause, if isGamePaused is true, we deactivate the pause panel to hide it. Else, we take pause panel and activate it. Save that. Pause button selected here, on-click here, and I click plus. Drag UI canvas here, and from its UI controller script, we want to call toggle pause. But it's not here, and that's because I set it to private in my script. Let's set it to public. Save that. UI canvas here, and here UI controller.togglePause. And also on close button. UI canvas here, and when click, we want to run UI controller toggle pause. Close button is only visible if pause panel is visible, so it will always just hide the pause panel. Back in my script, when we hide the pause panel, we set isGamePaused to false. When we show the panel, we set isGamePaused to true. Save that. I deactivate pause panel here, and I enter play mode. I click this pause button to show pause panel. I click the close button to close pause panel, and I can also click the pause button repeatedly, and it will toggle pause panel on and off. It works perfectly. I exit play mode. Now I want to show and hide pause panel also when we press a key on the keyboard. We will use the new input system we used before for detecting mouse clicks, so it will be inside the update method. And I say if keyboard. This will work if we have the new Unity Engine input system namespace up here. Checking if a key was pressed with the new input system is easy if you just want to react to a single immediate key press without needing complex input management. So here I check if the escape key was pressed on the keyboard, and if it was, we call toggle pause. Save that and let's play. I press escape and I click the close button. I click the pause button and I press escape to close it. Perfect. We also want the game to freeze when we pause. We already have a system for that, so here, when we unpause, I can just say GameManager.instance set timescale, and I set it to the last player specified game speed, like this. And when we pause, we set timescale to 0. Save and play. When I pause, the game freezes. When I unpause, the game resumes. But there is an issue. I open the tower panel, which also pauses the game, and when I press escape, we have pause panel overlaid over tower panel. I want to prevent this situation from happening. When tower panel is visible, we will not allow pause panel to appear for now. We might rework this later. Let's see. Inside toggle pause, if tower panel is active, return and don't run the rest of this code. Don't pause the game. Let's clean this indentation. OK. Save that and I play. I click one of the platforms to open tower panel, and now if I press escape, there will be no pause screen. We have a pretty nice game already, don't we? While tower panel is not active, I can pause the game by clicking this pause button or by pressing escape. When tower panel is open, clicking the pause button does nothing. I might change how this works later. Maybe opening pause panel could also close tower panel instead. That might be even better. For now, let's leave it like this. Or if you are confident in what you learned today, why don't you try to implement that functionality yourself and tell me in the comments how you did it. We have a pause panel. I want to put some buttons on it, a little menu that will give the player an option to restart and quit the game. I right-click pause panel and I select Create Empty. I will call it Button Group. This will be a simple wrapper that will help us keep the buttons aligned and evenly spaced out. I right-click it and I go for UI Button Text Mesh Pro. I will call it just Button. I set it to 350 by 100 pixels. Inside Assets Art, I have my Pixel UI sprite, so I expand it and I drag one of these rectangle outlines into the source image field on the button. It has a text element inside, so I select it. Font color white. Font size 35. Maybe set the height to 80 to make sure we can squeeze all of them here. We will need 4. Down here inside the button component, I can define how the button visually responds when the user interacts with it. I set it to color tint. We can define the colors for what happens to the button's appearance during different interaction states. Normal color is when the button is idle. Highlighted color is when the user hovers or navigates over the button. I will choose some colors here, but you can pick any colors you want. It doesn't really matter at this point. We can change them later to match our game art, depending on which asset pack we decide to use. Pressed color is when the button is clicked or tapped. Selected color is when the button is selected via keyboard or controller navigation, and disabled color is when the button is not interactable. If I play and I hover over the button, if I select and unselect it, you can see it changes colors based on those state changes. I exit play mode. I don't want to have to set up each button individually one by one like this. Let's turn this one into a reusable prefab. Inside Assets Prefabs, I create a folder I call UI. I drag the tower card prefab inside, and I will drag the button we created inside as well, turning it into a prefab. Now it's turned blue, and I can delete it from the scene. I can now duplicate it as many times as I want, and they will all be set up in the same way. I drag and drop it over button group to make sure it's nested under it. I do it 3 more times, so I have 4 buttons. Currently all of them overlapping each other. With button group selected, I add component, vertical layout group, anchor presets, Shift and Alt, and I go for center middle. I add one more component called content size fitter. It will make the element resize automatically based on the size of the child elements. So in this case, it will make button group resize to wrap around all the buttons. I make sure it adjusts its vertical and also its horizontal size. Since we already gave it a center middle anchor point, it will center the entire group of buttons in the middle of the screen. Let's give them some spacing, maybe 20. Alright. Button group selected, and I set vertical position to -50. Okay, I'm happy with the layout. I rename the first one to Resume Button. Its nested text component will say Resume. I select Resume Button again, and I go down here to OnClick, and I click plus. Resume Button will close the panel. It will unpause the game, so I put UI Canvas here. And on its UI controller component, I want to run toggle pause. The second button now, I rename it to Restart Level Button. Its text element here will say Restart Level. The third button will be called Main Menu Button. Its text will say Main Menu. The fourth button will be Quit Game Button. Its text will say Quit Game. So this will be our pause menu. We can do many things here, as you can see. By default, pause panel is hidden. I play. I pause the game, and all the buttons have their hover animations changing colors. Right now I can't click any buttons, but I also clicked the platform under the panel and it opened Tower panel underneath. That is an easy fix. I exit play mode. Let's open platform script. I want to make sure we can't click platforms when the game is paused. So let's add an OR operator here. If Tower panel is open, or if time.timescale is 0 for any other reason, like for example when pause panel is active, we will return early and we will not be detecting any platform clicks. Save and play. When Tower panel is open, I can't pause the game and show the pause panel. Good. Close that and escape to pause the game. When the game is paused, timescale is 0, and I can click buttons, but if I click any of these platforms in the background, they are not triggering tower panel. Perfect. I exit play mode and I make pause panel visible. We want to create a function to restart the level and to quit the game. These are very easy. Inside UI controller, I create a public method I call restart level. First, I set timescale back to 1 because the game is most likely paused when this code runs. And then we will use scene management. We will need to be using Unity Engine scene management namespace up here. I create a variable, type is scene, and I call it current scene. I simply want to reload the current scene we have open in Unity, which will restart the level. We get the current active scene using scene manager getActiveScene. And then we call scene manager load scene, which can take either the name of the scene or an integer of that scene's build index. We will cover that a bit later when we build a playable version of the game. To restart the game, to reload the current scene, we call load scene and we pass it the current scene.buildIndex, like this. Restart level button selected, on-click block here and plus. I drag UI canvas here, and on its UI controller component, I find the public restart level method we just wrote. I deactivate the pause panel and I will play to test it. Okay, so let's speed up and play some towers. I pause the game, and if I click resume, we unpause. And if I pause again and I restart the level, everything restarts to the default original state. I place a few towers and restart again. Yes, this works. Quit game is even easier. I create a public function I call quit game. And inside I say application.quit. And that's it. This will not do anything inside the Unity editor, but when we create a playable build, this will quit the application. If I wanted to quit the play mode in the Unity editor here as well, I can do this syntax. If we are in Unity editor, call unityeditor.editApplication.isPlayIn and set it to false. This will exit play mode. Else, meaning we are not in the editor, we are in a playable build, call application quit, and I end if like this. Sometimes this syntax can cause issues and we don't really need to quit game in the editor, but let's see if it works for me. I save that, quit game button selected, and here in onClick, I click plus, I drag and drop UI canvas in here, and when we click quit game button, I want to run UI controller quit game like this. I enter play mode, pause game, and quit game will exit play mode in the editor. That works. Play again, pause game, and quit game will exit play mode. We have one more button for main menu here. We will handle that next. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Main menu will be a separate scene. Let's learn how to transition between different scenes in Unity. I go to Assets Scenes folder. So far, we have only the main game scene here. I right-click Create Scene, like this. I rename it to Main Menu. I double-click it to open it. You can see the hierarchy is empty. All those game objects we created exist only in the game scene. We can still reuse things from the other scene. We don't have to build everything from scratch here, but let's start simple. I right-click here in the empty space. I go to UI Text Mesh Pro. You can see it automatically created canvas, because UI elements in Unity only function properly when placed under a canvas. Without a canvas as their parent, they won't render or behave as expected in the UI system. They need to be inside the canvas to be visible on screen. You can see that Unity also automatically created Event System, which is a core part of Unity's UI. It handles interactivity with mouse clicks, keyboard navigation, and so on. I renamed the text to title, and let's call our game, for example, Tower Defenders for now. We know that canvas is huge by default, but in game view, it still overlays the visible game area and it scales. You can see this tower word is very small down here. We can work with canvas like this, but I prefer to shrink it. I rename it to Main Menu Canvas. I set its render mode to Screen Space Camera, and I drag Main Camera into this new Render Camera field. Doing this will make sure that the canvas size matches the size of the assigned camera's viewport. I prefer to work with UI elements like this. Title selected, anchor presets, Shift and Alt, and I will use middle stretch settings. Font size 150, alignment center middle. Down here I add component, content size fitter. I set horizontal and vertical fit to preferred size, which means it will wrap around the text, adjusting to its size. The content size fitter tells Unity to automatically resize the rect transform of the text element to match the text content's preferred size. That's our simple provisional game title. I right-click Main Menu Canvas and I create empty. We need a wrapper for the buttons to keep them aligned. I will call it Button Group. Project assets like these prefabs exist across the scenes. They can be added and reused anywhere. So let's grab Button Prefab and parent it under Button Group, like this. And we will need one more. 2 buttons should be enough for now. Button Group selected, add component, content size fitter, and horizontal and vertical fit is preferred size again. Add one more component, vertical layout group, child alignment middle center, spacing 50. I right-click Main Menu Canvas and let's create one more empty game object. I will call it UI Container. I make sure it's nested under Main Menu Canvas, and title and button group will be its children, like this. UI Container selected. I add component, vertical layout group, child alignment is middle center, spacing 100. Add component, content size fitter, and I make sure I set these to preferred size, which will automatically set its width and height to fit all the elements it contains. Now that it has the correct width and height, it will also go into middle center of the screen. Maybe I move it 50 pixels up, like this. This is a very simple main menu, but we can add art assets, animations, or whatever we want. I rename the first button to New Game Button. The second one to Quit Game Button. Text inside here will say New Game. And here it will say Quit Game. If I enter play mode, you can see that our buttons that come from a prefab already have the basic set of animations. Inside Assets Scripts, I create a new monobehavior script. I will call it Main Menu Controller. I attach it as a component to UI Container and I open the script. Here I want to have a public method called Start New Game. It's public because I will attach it to buttons on-click event inside the Unity Inspector. Inside, we will use Scene Manager, so I will need Unity Engine Scene Management namespace. I call Load Scene, and here I can give it scene's build index, or I can pass it a string with the name of the scene. New Game will load the game scene, like this. I have to make sure this word game is spelled exactly as we named the scene we want to load inside Assets Scenes folder. So Start New Game is easy. Just load the game scene. Quit Game is also easy. Public void quit game method, and inside I run application quit. We know this will only work inside a playable build. It will not quit the game inside Unity editor. I save that, and I will actually put that script on a different game object. UI container selected here, and I remove main menu controller from here. Instead, I will add it as a component on main menu canvas. On New Game button, down here, inside onClick, I go plus, main menu canvas in here, and main menu controller, and Start New Game. Quit Game button here, onClick plus, main menu canvas goes here, main menu controller script, and Quit Game method. If I save and play, clicking New Game will load the game scene, and this is how we can travel between scenes in Unity. Pretty useful for so many things. Now I want to be able to click this main menu button and load the main menu scene from here. I save changes to main menu scene, and I go back to game scene. I go to File, Build Settings, and Scene List here. If I want to load a scene with code, like we just did, that scene has to be here in the scene list. I can simply drag it in, and I put main menu first and game second. You can see they have build index 0 and 1. We can use names of the scenes or their build indexes to load them. Okay, so when we click this main menu button, I want to load this main menu scene. We already know how to do that. UI controller script, let's go all the way down, and I create public void go to main menu method. My auto indentation is getting confused by this syntax, so let's delete all this code. We don't need the quit game button to exit play mode. I will keep it simple, like this. This will quit the game when we create a playable build. When I go to main menu, it will most likely be when the game is paused. So first, we set timescale to 1. Then I take Scene Manager and load scene main menu. Save that. Main menu button selected, plus UI canvas goes here, and we call UI controller script and its go to main menu method. I play. Escape to pause the game. I click main menu button and main menu scene is loaded. I click new game and game scene is loaded. I can go back and forth between game scene and main menu scene. In a similar way, you can create individual levels, one scene per level, load in the next level scene when we complete a win condition, for example after we survived 20 enemy waves or something like that. I want to create a game over scene. Inside enemy script, we have this onEnemyReachedEnd method. If enemy manages to reach the end of the path before towers destroy it, players will lose a life. Inside Game Manager, we are dealing with that here inside handleEnemyReachedEnd. We reduce player lives based on the incoming enemy damage, and we invoke onLivesChanged event, carrying with it the updated lives value. UI controller reacts to that by running its update lives text method, which takes that reduce lives value and it updates lives text display. In here, I will check if current lives are less than 0. If so, we will run showGameOver method. I will comment it out just for a moment, and I will save and go back to Unity. I right-click Canvas, UI, Panel. Game Over panel will look a little bit different than Pause panel. It will be full screen. I set the color to black and alpha to 250, only a little bit of transparency. I go here to Pause panel, I hold down Ctrl and select title and the entire button group, and I copy it. This new panel selected, I paste title and button group, making sure they are nested under it as its child objects, like this. I rename the panel to Game Over panel. Title will say Game Over. In the button group that we copied from Pause panel, I delete the Resume button. After Game Over, we will have options to restart the level, go to main menu, or quit the game. We copied these buttons, so they are already fully set up and working. I will deactivate Game Over panel. It will be hidden initially. Inside UI controller script, I need a field for Game Over panel, as usual. You probably already know how to do this. Save that. I see the new field here on UI canvas, and I drag Game Over panel in. Back to UI controller script. And down here, I can define my private show game over method. First, we make sure the game runs at normal speed. And I take Game Over panel and set active true to show it. Now I can uncomment show game over here to call it when the current player lives drop below 0. Save that and let's play. We have 5 lives. So when we allow enemies to reach the end, we will get a game over. I exit play mode. Actually, let's set timescale to 0 when game over happens. I go to Assets Prefabs and I will hide the waypoint sprites by disabling their sprite renderer component here. Let's play. Again, I speed it up. Enemies still follow the path, but the waypoints are hidden. When the enemies reach the end and the player loses all 5 lives, we get a game over screen and the game freezes. Timescale is set to 0. I can go to the main menu by clicking this button. I can start a new game like this. We have all the key features in place. We can just expand on this further, give it nice graphics, and try to follow the same coding patterns we introduced so far to keep our codebase consistent. Maybe you've already put in some background artwork with a nice game world at this point. I'm keeping it generic still at this stage. Let's learn how to create a playable build. Unity makes it very easy to package your game into a standalone, runnable version that can be distributed and executed outside the Unity editor. It is able to generate files needed to upload your game to Steam, App Store, and so on. Sometimes builds can also reveal platform-specific issues and bottlenecks not visible in the editor. We will encounter one and learn how to fix it. If I go to File, Build Profiles, we make sure all our scenes are here in the scene list. If some are missing, you can just drag and drop them here. As you can see here, Unity supports building for a wide range of platforms, including desktop, mobile, web, consoles, and even extended reality. I'm working on a Windows machine right now, and you can see my Windows build profile is active. If I wanted to build a web game playable in a browser, I would select Web here and click Switch Platform. Console development like PlayStation or Nintendo might require a special Unity license or a registration as a developer with the platform holder, so let's start with something simple. This is a beginner class. If you are on a Mac, make sure you install the Mac build module, and then you'll be able to see the Switch Platform button here and build your game for Mac. I will create a playable Windows build. I click Build, and I navigate to an empty folder somewhere on my computer where I want to create the necessary files. It should be a different folder than where your Unity project is. Let's keep the builds separate. Create your folder, go inside, and click Select Folder. This will trigger a compilation process, but almost immediately I get a bug. And to make things even more challenging, my console will show the bug only for a second, and then it will clear. We can change settings in the console to uncheck Clear on Play or Clear on Build, or we can also check a persistent log file that Unity keeps on your system. In there, the error message during the build process, if an error happens, will guide you to the problematic script file. It's usually a script or a library issue. In our case, the issue is here inside the path script file that we wrote all the way in the beginning. I will wrap this line in a special syntax. This means only include using Unity Editor if the script is being compiled inside the Unity Editor and exclude it for builds for other platforms like Windows or Mac or WebGL. I will do the same thing here. This code will not be executed if we are not compiling it inside Unity Editor. We use this to display helper labels above waypoints. It is not meant to be visible in the final game. Handles is an editor-only API. It's not available in runtime builds, and that's why I'm getting an error when creating a Windows build. Now it will be excluded, so I save that. I go to File, Build Profiles. I make sure my build is active. All scenes are in the scene list. And I go to Build again. I select the folder where I want to create all the necessary files, and I wait for the process to finish. This can take some time depending on the size of the project and the processing power of your computer. When it's done, I have a folder with my playable Windows build. When I click this exe file, my game opens as a full-screen, playable standalone application. We can choose towers to place. We are destroying enemies and gaining resources to buy more towers. We have a pretty good game here. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. When you click a platform, you can place a tower. But look what happens when I click the same platform again. I get to choose another tower, and I can place multiple towers on the same platform. We want to prevent that. I can handle that in multiple places, but I think the easiest way to fix it is here inside the UI controller, inside Handle Tower Selected method. If you remember, when we place a tower, it becomes a nested child element of the platform it was placed on. So here, when Handle Tower Selected method runs, I say, if current platform.transform.child count is more than 0, we hide tower panel and we return, preventing the rest of the code in this function to run, which means place tower method will not run and no tower will be placed on the occupied platform. Save and play to test it. I place a tower. I click that same, now occupied platform, and I select another tower. The tower panel closes and no second tower was placed. I exit play mode. Let's use this no resources text to show all different kinds of warning messages, like in this case, to tell the player that the platform they chose already has a tower. I rename it to warning text. Inside UI controller, up here, I rename no resources text field to warning text. Down here, inside show no resources message, I replace no resources text with warning text in 2 places. And in these 2 places, I rename show no resources message to show warning message. Save that, and in Unity, the field lost the reference. I drag warning text game object into warning text field here. Now that the field is connected again, I want to use this show warning message method to send different warning messages to it, depending on situation. Show warning message will take a parameter, type is string, and I call it message. Now, when I call it here, it will need some value, so I pass it not enough resources as an argument, because this block runs if we are trying to place a tower, but we can't afford it. When we call this, we will take warning text.text and we set it to the message that is being passed to it. So for example, this not enough resources text. You can see I'm getting a compilation error here. It's because warning text needs to be a different type. Right now it's game object, but to be able to access its text component in the way I'm trying to, it needs to be TMP text. Save that. I'm trying to access this warning text game object and its text component here. Changing field type from game object to TMP text means that I have to access the game object here, like this, to be able to set active true and to false here, like this. Okay, so when we call show warning message, we always have to pass it some text we want to display. We set message value to the text field here. We show it, we wait for 3 seconds, and we hide it. Save that. I make sure we have a reference to warning text and we haven't lost it because we changed the data type. All is good, so I enter play mode. I place a tower. Now I don't have enough resources to afford this tower that costs 100, so if I try to choose it, I get not enough resources warning. That still works. Exit play mode. I do lowercase r here. If you are trying to place a tower on a platform that already has a tower, we will also call show warning message like this. But I want to show a message that says this platform already has a tower. Save that and play. I place a tower here. I select the same platform that already has a tower, and I select another tower. Tower panel closes, and I get a warning message saying this platform already has a tower. Perfect. We have a simple warning message system. We can reuse this later for other kinds of warning or status messages. Maybe at the start of each level, I want to have a text that will appear for a limited time, showing the mission objective. Something like survive 20 waves to finish the level. Let's implement that. I right-click UI Canvas and I create a new text element. I make sure it's nested under UI Canvas and I rename it to objective text. The text field will say something like objective text as the default value. It doesn't really matter. Anchor presets and I set it to bottom center. Width will be 1100, height is 100. Alignment middle center, font size 80. Vertical position may be 50 to move it a bit up. By default, it will be disabled. Inside UI controller script, I define a new field for it. Type is TMP text. And I call it objective text. Save that. UI Canvas selected. And I drag objective text game object into this new field here. Let's say I want to run this every time a level starts or restarts. In our case, that means that a scene was loaded or reloaded. We can use onSceneLoaded method that runs after a new scene has fully finished loading. For that to run, we need to use Scene Manager here, which needs Unity Engine Scene Management namespace. And we subscribe to Scene Manager Scene Loaded, a static Unity event that fires after a new scene has finished loading. As a reaction to it, we will run our onSceneLoaded method. I also make sure I unsubscribe, as usual. You can see it's complaining about something, and that is because this onSceneLoaded method needs to be able to accept two parameters, scene, and load scene mode, what scene was loaded, and how it was loaded. We don't need to use these for anything right now, but we need to include them here for Unity to allow us to subscribe to that static scene loaded event. Now that we included those parameters, you can see it accepts this line up here, so it will all work. Here we can put anything we want to happen every time a scene is loaded or reloaded. I want to show that objective text for a few seconds, so let's again use IEnumerator that we used to show the warning message for 3 seconds before. I will call it show objective. On scene loaded here, I will start coroutine and I pass it this show objective. Inside, we will wait 5 seconds, so yield, return, new, wait 4 seconds, 5F. But before that, I first set the message text to whatever I want to display. I will use string interpolation, a syntax that will allow us to include a variable inside this string to replace this XXX with a value from our data. Then we show the objective text like this. We wait for 5 seconds, and we hide it. Let's create some level data. Let's say each level will have a different win condition, a different number of waves the player has to survive to complete the mission. If I save and play, we will see this objective text appear for 5 seconds. I exit play mode. Inside Scriptable Objects, I create a new folder I call Level. We will follow the same pattern we did before for enemy data, tower data, and waves data. Inside, I right-click and I go to Create, Script in, Scriptable Object Script. I call it Level Data, and I open it. Here I have to think, what kind of data do we want to define for each game level? We will need public string level name. This has to match a scene name. We will use this value to load next level. Each level will also have integer waves to win, how many enemy waves the player has to survive to complete the mission. Maybe we also want each level to have different starting resources. This value will affect how many towers we can place in the beginning of the level. Tweaking it can make the level much easier or harder to beat. We also might want to set different starting lives for the player for each level. How many enemies can reach the end of the path before we get a game over? We can do so many other things here. For example, each level can have different background music and so on. We can really put a lot in here, but let's comment this out and focus on the 4 main fields for now and learn how to actually connect them to our game logic. Save that. We have a blueprint for level data, so if I go inside this folder and I right-click, I can go to Create, Scriptable Objects, Level Data, and I create a data file for level 1. Level name will be level 1 here. Waves to win is 2, just for testing. Starting resources 180. Starting lives 5. OK, I right-click again and I create level data for level 2. Level name is level 2. 5 waves to win, 300 starting resources, and 3 starting lives. Doing this allows us to set up each level with different starting properties. Let's just focus on level 1 data file here. We can do the next part inside Game Manager, but I will actually separate the logic into Level Manager to keep it cleaner. I create a new blank game object and I call it Level Manager. I reset its transform here. Inside the scripts folder, I create a new monobehavior script. I attach Level Manager script as a component to Level Manager game object. I open it in my code editor. I will give it a public static instance to make it easily available to other scripts in the scene. As always with singleton, I have to check if this is the only instance. And if I find a duplicate, I destroy it. Otherwise, set this to the instance. This makes sure we always have only one Level Manager instance. Level Manager will have a public level data array I call all levels. It's an array holding data files for all levels we have inside the game. Level Manager will also keep track of which one of these data assets is the currently active level, and we set this to a public read-only property. If I save that, I select Level Manager and I see all levels array here. From Scriptable Objects Level folder, I drag Level 1 data file and Level 2 data file into the array. Back in the script, all levels array here contains data for all the levels we created, and inside awake, we set current level to all levels at index 0. When Level Manager is first loaded, we set the current level to level 1, basically, the first element in all levels array. So the job of Level Manager is to keep track of all levels and to always be aware which one of them is the current level. We can also use it to load levels later if we decide to build more. So far we've only built one map here. If I check my data file for level 1, I have all these values in here, and because we put this into level data array and we're setting current level to the first index in that array, at this moment current level property is pointing to this data file, and from it we can access all these values when we need them. We turned Level Manager into a public static instance, and current level is a public property, so I can now access this level data from other scripts. For example, let's access this waves to win value that we set to 2. We need it here inside show objective on UI controller. I can put a dynamic variable into the string like this. I want to access levelManager.instance and its current level property, which currently points to this data file. And that's why I can access waves to win. If I save and play, let's see if it shows number 2. It does. I exit play mode. To be absolutely sure, I put a different value in the data, 1540. And yes, it says survive 1540 waves. I exit play mode and I set this to 3. We have this level data available all over our codebase. Wherever in this scene, we might need it. So let's now make sure when we start the level, we get 180 starting resources and 5 starting lives, or whatever value we put inside this data. We can do that inside Game Manager script. I will create a public method I call resetGameState. Inside, I set lives to level manager, instance, current level, starting lives. Save that. Let's just open level 1 data file so I can see it side by side. Okay, so I'm setting lives to starting lives from the data here. We know that whenever lives value changes, we want to update the UI display as well to show the current lives value to the player. We do that by invoking onLivesChanged event that UI controller is listening to, and it will update lives text based on the lives value we broadcast here. We will do the same thing with resources. We set resources to level manager, instance, current level, starting resources, so from the data coming from here. And we will invoke onResourcesChanged so that UI controller can update UI. We will also set game speed to 1. In case we are resetting the game from the game over screen, where the time.timescale is set to 0. I want this method to run when a scene is loaded, so we will do the same thing we already did. I take Scene Manager. I make sure I'm using Unity Engine Scene Management namespace. We will subscribe to SceneLoaded event with onSceneLoaded method that we haven't written yet. And we also remember to unsubscribe. Let's define private void onSceneLoaded here. For it to work, we need to make sure it expects these parameters, scene, and load scene mode, even though we don't need them for anything right now. When the scene is loaded, we run resetGameState that sets lives and resources to the values from level data, and it sets game speed to 1, the normal speed. Alright, with level 1 data asset selected, I set starting lives to 700 and starting resources to 10,000, just to see if the values are coming through. I play, and we have 700 lives and 10,000 resources. Perfect. I exit play mode. I set this maybe to 300 and this to 8 for now. Next, we will need a Mission Complete panel. When we survive the number of waves specified in the data, we will get a Mission Complete, where we can go to the next level. And maybe we will also do endless mode to see how many waves we can beat. Mission Complete panel will look very similar to Game Over panel, so I select Game Over panel here and I copy and paste it to create a duplicate. I rename the duplicate to Mission Complete panel, and I make sure it's nested under UI canvas, otherwise it won't render for us. I enable it to make it visible, and inside Mission Complete panel and its title object, I set the text to Mission Complete. I increase the width to 1100 pixels, and the vertical position will be maybe -180. Yes. Okay. Initially it will be hidden, so I disable it here. Now we want to show and hide Mission Complete panel with code, so we will need a field for it inside UI controller. Game object I call Mission Complete panel. Save that. And on UI canvas I set the new field here, so I drag Mission Complete panel inside. We will have a private function I call showMissionComplete. Save that. And I open spawner script because this is where we handle enemy waves. We will give it a new event. I will call it onMissionComplete. It will not carry any value with it. It will be simple, like this. This wave spawning logic is a little bit complicated in this part. Not sure if you remember when we wrote this, but basically, whenever we are about to go to the next wave, before we actually increase wave counter, we will check if wave counter +1, the upcoming wave, is greater than or equal to waves to win, coming from level manager, instance, current level, from our current level data. So, if we already defeated enough waves to pass this waves to win check, we can complete the mission. I make spawner script invoke this onMissionComplete event. And after that I return, so we are no longer increasing waves further. If we defeated enough waves, none of this code will run after that. Spawner is invoking onMissionComplete event, so inside UI controller we will subscribe to it, and we will react to it by running showMissionComplete method. And here we also unsubscribe. When showMissionComplete method runs, we take MissionComplete panel and we activate it. We take Game Manager and we set time.timescale to 0 to freeze the game. Save that. And here inside level 1 data, I set waves to win to 1, just for testing. After we defeat one wave, we should get MissionComplete panel. I play. Let's make sure we destroy all enemies. And we have mission complete. Nice. We have the option to restart the game, go to main menu, or to quit the game. I restart, and it works. Great. I exit play mode. I make mission complete screen visible, and I want to add 2 more buttons here. One for the next level, and one for endless mode. I go to Assets, Prefabs, UI folder. We have this button group inside MissionComplete panel. I take button prefab and I drag and drop it over the button group. And I drag one more. I make sure both of them are nested under button group game object. I select the first one. I rename it to next level button. And down here inside its button component, I unchecked interactable. Right now, the button will be here, but it will be disabled. We are not doing multiple levels yet. The text inside will say next level. I drag the button to the top to make sure it's the first option. Okay, so we have a non-interactable next level button. The second button, I rename it to endless mode button. The text will say endless mode. When we enable it, the idea is that we can just continue the level and play as long as we can survive against the endlessly more and more difficult enemy waves. We already implemented logic earlier that increases enemy health with each wave. So when mission complete screen appears, we have these 5 buttons to click. I open spawner script. In this code block, we are preventing waves counter from increasing if we've reached the waves to win limit. But when we decide to enter endless mode, we want to keep moving past that point, so we will only run this block and return if isEndlessMode is false. Exclamation mark means false. We haven't defined that variable yet, so I go up here and I define a private bool I call isEndlessMode. And initially I set it to false. If isEndlessMode is true, we will keep increasing waves even past waves to win limit. Down here, let's define a public enableEndlessMode method. When called, it will switch this flag isEndlessMode to true, allowing spawner to keep spawning more and more waves because of this logic we wrote here on line 64. When we first complete the level, isEndlessMode is false, so onMissionComplete will be invoked and we will get mission complete screen. If we click the endless mode button, that click will set isEndlessMode to true, which means that level continues because this block will be skipped. So all we have to do now, if I want endless mode, is to make sure that isEndlessMode is set to true. by calling the public enable endless mode method we just wrote inside spawner. To be able to call that method, I will turn spawner into a singleton, public static instance, like this. We did that before for game manager, for example. So I can actually copy this code inside awake method from game manager script, and I paste it down here. This code makes sure we only have one spawner instance. Okay, so we are all set up. To enable endless mode, all I have to do is to take this public static spawner instance, and from it I call enable endless mode method, which sets the isEndlessMode flag to true. Now, finally, I go to UI controller script, and down here I define a public enter endless mode method, and inside we hide mission complete panel. We set time.timescale to the last recorded player selected speed, like this. And I take that new spawner instance, and from it I call the public enable endless mode method we just wrote 2 minutes ago. Save that. On mission complete panel and its endless mode button, down here inside its button components on click block, I click plus. We put UI canvas in here, and we call UI controller enter endless mode. That will do it. I select mission complete panel and I disable it. Inside Scriptable Objects level folder and level 1 data, I set waves to win to 2. Let's play to test it. I need to place some towers and defeat 2 waves of enemies to win. Okay, first wave down, second wave of dragons is coming, and when I destroy all of them, I get mission complete panel. Next level button is non-interactable, but I can click this endless mode button and we continue with the level. We kept all our towers, resources and lives, and we are on wave 3. We are in endless mode. Now the game will end only with a game over when we can't prevent enemies from reaching the end of the path and we lose all 8 lives. It might take a while because enemy scaling is pretty forgiving. So I exit play mode and we scale enemy health here on line 114 inside spawner script. Every time we move on to the next wave, we increase enemy health by 10%. Let's make it a bit more challenging. I will increase enemy health by 40% each time. Also, let's do one more thing. Here in level 1 data asset, I set level name to level 1. I go to assets scenes and I rename game scene to level 1, making sure it's spelled exactly like this. This can be used to load next levels if we decide to create a scene for level 2, level 3 and so on. By renaming the scene, we broke a few things, but it's an easy fix. I open level manager and I create a public load level method. This method will be able to reload the current level or load next levels if we create some. It will take one parameter, type is level data, and I call it level data. Whatever level data we pass to it, we load a scene with that name, basically. We set current level to that new level data we are loading here. Then we take scene manager, as always making sure we include Unity Engine scene management namespace, and we call load scene. We know it can be called in 2 ways, by passing it a scene name or by passing it a build index. That's why inside level data, under level name field, we make sure we put a value that exactly matches how we call the scene file. So we are loading by scene name here. I name the scene I want to load level 1. So the thing that is broken, if I open main menu scene and I play, I click New Game, which will try to call the scene we renamed from game to level 1, so it will not load. I exit play mode, I open main menu controller, and here we are trying to load the scene by its old name. So instead of hardcoding that, I will use this public load level method we just wrote. I do it by taking level manager instance, load level, And if you remember, on Level Manager instance, we are keeping an array of all levels. And this is the start new game method, so we always want to load the first level in that list, the element with index 0. Okay, keep in mind we are inside main menu scene, and I'm trying to do this by using Level Manager. I save that and I play. And now, when I click New Game, I get an error. Why is that? I exit play mode. The problem is that if you look here, there is no Level Manager game object, but I need it here to load that next scene. If I open Level 1 scene, this is where Level Manager is. We turned it into a public static instance, but it still exists only in Level 1 scene. Main menu scene doesn't have access to this Level Manager. I will copy Level Manager in this scene. I open main menu scene and I paste it here. That will fix it, but we don't really want to have copies in both scenes. Those copies are independent. In theory, I would have to make sure I always update both of them. This Level Manager is actually simple enough that we could do that, but a proper way is to have only one Level Manager game object that can jump between scenes instead of being destroyed. That way, I have just one Level Manager, but it's always available in every scene across our project. To do that, I go inside Awake. Here, if we detect a duplicate Level Manager, we destroy this duplicate. If this is the only Level Manager in the scene, we set it as the instance, and we make sure it's not destroyed when jumping between scenes. Don't destroy on load. And I pass it this Level Manager game object that I want to make sure is not destroyed. I save that. I make sure I save changes to all my scenes. Currently, I have two copies of Level Manager, one in main menu scene, one in Level 1 scene. It will work because the one that is in the scene where we start playing will be marked as don't destroy on load, and when we enter the other scene, the duplicate will be destroyed because of the logic we wrote inside Awake. Having it in both scenes has an advantage that we can enter play mode from both scenes. If I enter play mode now and I open this don't destroy on load, we will see Level Manager here. Now I can click New Game and Level Manager will load Level 1 scene. As you can see, the main Level Manager survived here and the duplicate is gone. It was destroyed. I can restart the level, or I can go to main menu. Both of these things are loaded in a scene. Inside UI controller, I have restart level function here. It does two things. It sets time.timescale to 1 and gets the active scene and loads it. We don't really need to set timescale here because here, inside Game Manager, we have this on scene loaded. And every time a scene gets loaded, we already set game speed to 1, so restarting level reloads a scene. We don't need this line here. And I want to replace these two lines with our new way of loading levels using the ever-present Level Manager that will be available in all our scenes. And we call the load level method, and we pass it the level we want to load. When we restart level, we want to load the current level we are playing right now. We store that in the current level property, like this. Now if I play, I can still restart a level. I can increase game speed, play some towers, and restarting level resets the game speed to normal. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Now it's time for a little challenge. We learned how to load scene and how to create game objects that persist across multiple scenes, like this Level Manager. Can you use what we learned and create Level 2 and Level 3 scenes? And when the player completes a mission objective, they will see Mission Complete screen appear, and they will be able to click Next Level button to load that next level. There are many ways to achieve this, but following the pattern we have here, my tip would be to set Game Manager as Don't Destroy on load, so that we have one that exists across all our scenes. And I would also do that with UI controller, because there is a lot of logic that we need in every level, and we don't want to be managing independent UI for each scene, because making a change to one would not change the others that way. If you need a little help from me and you want me to show you exactly how to do it, step by step, I created an optional extended class. In there, we implement 3 game levels, but we will also play with pixel art graphics and add a lot of detail and polish. For example, we will learn how to create this shadow projection when the player is hovering over platforms to indicate they can place a tower there. We will create a dust cloud animation when placing a tower, and we will also talk about how to animate the tower every time it attacks. For example, we will implement a system for sound effects. I will also give you full final source code there as usual. If I decide to create a playable version, there is a link to that somewhere down below. All these things are completely optional, you already have a fully functional game here. Well done if you got all the way here, this was a big one.